When you look up at the night sky, something ancient stirs within you. Perhaps it is the same feeling that moved our earliest ancestors to wonder what lay beyond the hills, beyond the rivers, beyond the horizon they could see from their caves. We are a species defined by our desire to reach further, to go beyond, to find edges and then cross them. And so it is only natural that when we gaze into the cosmic darkness and see those distant points of light scattered across the heavens, we ask ourselves a question that feels both simple and profound. Can we ever travel to the edge of the universe? The question seems straightforward enough. After all, edges are familiar things. Every object we have ever touched has an edge. Every room has walls. Every ocean has a shore. Every forest has a boundary where the trees give way to something else. Our entire lived experience tells us that things have limits, that spaces have endings, that if you travel far enough in any direction, you will eventually arrive somewhere different, somewhere that marks the end of one thing and the beginning of another. So when we imagine the universe, our minds naturally paint a similar picture. Somewhere out there, we think, there must be an edge, a boundary, a place where the cosmos stops and something else begins. Perhaps it is a wall of some kind, or perhaps it is simply emptiness, a void beyond which nothing exists. Either way, we imagine that if we could build a fast enough ship and travel for long enough, we could reach it. But here is where our journey begins to take an unexpected turn. Because the universe, as it turns out, does not behave like a forest or an ocean. It does not follow the rules that govern the objects of our everyday experience. And the question of whether we can travel to its edge is not really a question about engineering or technology or willpower. It is a question about the very nature of space and time themselves. It is a question that forces us to confront ideas that challenge our deepest intuitions about what distance means, what travel means, and what it means for something to have an edge at all. To begin understanding why this question is so much more complex than it first appears, we need to start with something that might seem obvious, but is actually quite profound. The universe is very, very large. This is a statement that everyone knows in some abstract sense, but very few people truly grasp in their bones. We say the words, "The universe is large," the way we might say, "The ocean is deep," or "The mountain is tall." We acknowledge the fact without really feeling it, so let us take a moment to actually feel it. Consider the distance from where you are sitting right now to the nearest wall. Perhaps it is 3 meters away, perhaps 10. This is a distance you could cross in a few seconds. Now consider the distance to the nearest town or city center. Perhaps a few kilometers. You could walk there in an hour or drive there in minutes. Now consider the distance to the other side of your country. Depending on where you live, this might be hundreds or thousands of kilometers. You could fly there in a few hours. Now consider the distance to the other side of the planet. The Earth is about 40,000 kilometers in circumference. You could fly halfway around the world in about a day. These are all distances that, while large by human standards, are completely within our ability to traverse. They are distances that our technology has made routine. Now, let us step outward. The Moon, our nearest cosmic neighbor, orbits the Earth at an average distance of about 384,000 kilometers. This is roughly 10 times the circumference of Earth. When the Apollo astronauts traveled to the moon in 1969, the journey took about 3 days. That seems manageable enough. But consider that the moon is extraordinarily close by cosmic standards. It is practically touching us. In terms of the distances we will soon be discussing, the sun is about 150 million kilometers from Earth. This distance is so large that we have invented a special unit to describe it: the astronomical unit, or AU. 1 AU is the average distance from Earth to the sun. Light, traveling at about 300,000 kilometers per second, takes about 8 minutes to cover this distance. When you look at the sun, you are not seeing it as it is now, but as it was 8 minutes ago. The sunlight warming your face left the sun when you were perhaps still finishing your morning coffee. This is our first hint that distance and time are more intertwined than we usually realize. The outer planets of our solar system are much farther away. Neptune, the most distant major planet, orbits at about 30 AU from the Sun, or roughly 4.5 billion kilometers. The Voyager 1 spacecraft, launched in 1977 and traveling at about 17 kilometers per second, took over 12 years to reach Neptune's orbit. As of now, Voyager 1 is the most distant human-made object from Earth, currently over 23 billion kilometers away. It has been traveling for more than 4 decades, and it is still, by cosmic standards, essentially in our backyard. The nearest star to our Sun is Proxima Centauri, located about 4.25 light years away. A light year is the distance light travels in 1 year, which works out to roughly 9.5 trillion kilometers. So Proxima Centauri is about 40 trillion kilometers away. If Voyager 1 were heading toward Proxima Centauri, which it is not, it would take over 70,000 years to get there. 70,000 years. That is longer than modern humans have existed as a species. That is longer than all of recorded human history, multiplied many times over, and Proxima Centauri is our nearest stellar neighbor. Here is where scale begins to escape our intuition entirely. Our galaxy, the Milky Way, contains somewhere between 100 billion and 400 billion stars. It is a vast spiral structure, about 100,000 light years across. If you could travel at the speed of light, it would take you 100,000 years to cross from one side of our galaxy to the other. At the speed of Voyager 1, the journey would take about 1.5 billion years. The Milky Way is unimaginably large by any human standard, and yet it is just one galaxy among billions. The nearest major galaxy to our own is the Andromeda Galaxy, located about 2.5 million light years away. When you look at Andromeda in the night sky, you are seeing light that left that galaxy when our ancestors were still learning to chip stone tools. The light has been traveling through space for longer than humans have existed, and it is only just now reaching your eyes. And Andromeda is close in cosmic terms. It is part of our local group of galaxies, a small cluster bound together by gravity. Beyond the local group, galaxies stretch out in all directions, forming clusters and superclusters and vast cosmic filaments separated by enormous voids of nearly empty space. The observable universe contains roughly 2 trillion galaxies. 2 trillion. That number is so large that it loses all meaning. If you spent 1 second looking at each galaxy, it would take you over 60,000 years to see them all. The observable universe is about 93 billion light-years in diameter. This is the region of space from which light has had time to reach us since the universe began. And here is where we encounter our first crucial distinction, one that lies at the heart of the question we are trying to answer. The observable universe is not the same thing as the entire universe. The observable universe is simply the portion of the universe that we can see. Its edge is not a physical boundary in space. It is a horizon, a limit set by the finite speed of light and the finite age of the universe. Beyond this horizon, there is almost certainly more universe, more space, more galaxies. We simply cannot see them because their light has not had enough time to reach us. This distinction is essential, and it is often misunderstood. When people ask about traveling to the edge of the universe, they are sometimes imagining the edge of the observable universe, and sometimes imagining some kind of absolute edge, a place where space itself comes to an end. These are very different concepts, and they require very different answers. So let us examine each one carefully. The observable universe has an edge in a manner of speaking, but it is not an edge you could travel to. It is an edge that exists only in relation to the observer. Think of it this way. If you are standing in an open field on a clear day, you can see for several kilometers in every direction before the curvature of the earth limits your view. The horizon around you forms a circle, and you might say that you are at the center of your observable field. But if you walk a kilometer to the east, your horizon shifts with you. You can now see 1 kilometer further east than you could before, and 1 kilometer less far to the west. The horizon is not a real place in the landscape. It is a consequence of where you are standing and the geometry of the earth. The cosmic horizon works similarly, though the geometry is different. From Earth, we can see roughly 46 billion light-years in every direction. This means the observable universe appears as a sphere with Earth at its center and a radius of about 46 billion light-years. But there is nothing special about Earth. If you could somehow teleport to a galaxy 10 billion light-years away, you would find yourself at the center of a different observable sphere. Some of the galaxies visible from Earth would now be beyond your horizon, and some galaxies invisible from Earth would now be within view. The edge of the observable universe is not a wall or a barrier. It is simply the limit of what can be seen from a particular vantage point. You might wonder why the observable universe has a radius of 46 billion light-years, when the universe itself is only about 13.8 billion years old. Should not the light have traveled only 13.8 billion light-years in that time? This is an excellent question, and answering it requires us to understand something that will be central to everything that follows: the expansion of space. Space itself is expanding. This is not the same as saying that galaxies are moving through space away from each other, though that is often how it is described. Rather, the fabric of space itself is stretching, like the surface of a balloon being inflated. Imagine drawing dots on a balloon and then blowing it up. The dots move apart from each other, but they are not moving through the surface of the balloon. The surface itself is expanding, carrying the dots with it. In our universe, galaxies are like those dots. They are carried along by the expansion of space. This expansion has been happening since the beginning of the universe. Light that left distant galaxies billions of years ago has been traveling toward us all this time, but the space it has been traveling through has been stretching. By the time the light reaches us, the galaxy that emitted it has been carried even farther away by the expansion. A galaxy whose light has been traveling for 13 billion years is no longer 13 billion light years away. It is now much farther because space has expanded during the entire journey. The current distance to the edge of the observable universe is about 46 billion light years, precisely because of this expansion. Here is where something subtle but important happens. The expansion of space is happening everywhere, but it is only noticeable over very large distances. On small scales, like within our solar system, or even within our galaxy, the expansion is completely overwhelmed by gravitational forces that hold things together. The space between you and the nearest wall is technically expanding, but by an amount so small that it is utterly unmeasurable. The space between the Earth and the Moon is expanding, but the gravitational attraction between them keeps them bound together. Only on scales of millions or billions of light years does the expansion become significant. And on the largest scales, the expansion is not just happening, it is accelerating. This was one of the most surprising discoveries in modern cosmology, made in the late 1990s. By observing distant supernovae, astronomers found that the expansion of the universe is speeding up over time. Something is driving this acceleration, something we call dark energy, though we do not yet understand what it really is. All we know is that it makes up about 68% of the total energy content of the universe, and it is causing space to expand faster and faster. This accelerating expansion has profound implications for our question. It means that distant galaxies are receding from us not at a constant rate, but at an ever-increasing rate. And for galaxies far enough away, this rate of recession exceeds the speed of light. This might sound like a violation of Einstein's theory of relativity, which tells us that nothing can travel faster than light. But it is not a violation, because the galaxies are not moving through space faster than light. Space itself is expanding, carrying the galaxies along with it. There is no limit to how fast space can expand. This brings us to one of the most mind-bending aspects of our universe. There are galaxies that are receding from us faster than the speed of light. We can see some of them because they were closer to us in the past when their light was emitted, and the light has been traveling toward us even as the space between us has expanded. But we will never see new light from these galaxies. Any light they emit now will never reach us, because the space between us is expanding too fast. These galaxies are beyond our cosmic event horizon. They are visible, but unreachable, and they will become invisible over time as their old light fades and no new light arrives. Let us sit with this idea for a moment, because it is central to answering our original question. There are galaxies in the observable universe, galaxies we can see with our telescopes right now, that are already beyond our reach. No matter how fast we travel, no matter what technology we develop, we can never reach them. They are receding from us faster than light, and they will continue to recede faster forever, thanks to the accelerating expansion. Now consider what this means for the concept of traveling to the edge. If you imagine building a ship and setting out toward the edge of the observable universe, you might picture yourself traveling toward a destination that remains fixed in place, like sailing toward a distant island. You would expect that, however long the journey takes, you would eventually arrive. But this intuition is wrong. The edge is not a fixed destination. It is a horizon that recedes as you approach it. And thanks to the accelerating expansion, it recedes faster than you can ever travel. Let us think about this more concretely. Suppose you build a ship capable of traveling at 90% of the speed of light. This is an astonishing achievement, far beyond any technology we can currently imagine. At this speed, you could reach Proxima Centauri in about 4.5 years. As measured by someone on Earth, you could cross the entire Milky Way galaxy in about 111,000 years. These are still immense timescales, but they are not infinite. With enough patience and enough generations of travelers, you might imagine exploring a significant portion of the galaxy. But as you venture further, something troubling begins to happen. The galaxies you're trying to reach are not standing still. They are being carried away by the expansion of space. At first, this recession is slow, and you make progress. You cover the distance faster than it grows. But as you travel to more distant galaxies, the recession speed increases. At a certain distance, known as the Hubble radius, galaxies are receding at exactly the speed of light. Beyond this distance, they are receding faster than light. If you are traveling at 90% of the speed of light, you might think you could catch up to galaxies receding at, say, 80% of the speed of light. And indeed you can. But you cannot catch up to galaxies receding at 95% of the speed of light, or 100%, or more. There is a fundamental limit to how far you can travel, no matter how fast you go, and no matter how long you have. The expansion of space creates an insurmountable barrier, and this barrier is not static. Due to the accelerating expansion, it is actually shrinking over time. The portion of the universe that is reachable is getting smaller, not larger. As cosmic time passes, more and more galaxies will cross beyond the point where they can ever be reached. The universe is not only vast beyond comprehension, it is actively becoming more inaccessible with every passing moment. Let us now consider the energy requirements for such a journey, because even if we set aside the question of whether we can reach distant destinations, there is still the question of whether we could even attempt the journey in the first place. The physics of high-speed travel is unforgiving. According to Einstein's special relativity, as an object approaches the speed of light, its effective mass increases. This means that the energy required to accelerate it also increases. As you get closer and closer to the speed of light, the energy required approaches infinity. You can never quite reach the speed of light, only get arbitrarily close, and each incremental improvement costs exponentially more energy. To accelerate a single kilogram of matter to 90% of the speed of light requires about 58 trillion joules of energy. That is equivalent to about 14 kilotons of TNT, roughly the yield of the atomic bomb dropped on Hiroshima. To accelerate a modest spacecraft of, say, 1 million kilograms to the same speed would require the energy equivalent of 14 billion tons of TNT. This is more than all the nuclear weapons ever built, expended just to reach 90% of the speed of light. And this does not account for the energy needed to slow down at the destination, or to maintain life support during the journey, or to navigate around interstellar obstacles. At 99% of the speed of light, the energy requirements are even more extreme. At 99.9%, more extreme still. And even at these incredible speeds, you would still not be able to reach most of the observable universe. The energy that would be required to reach the most distant visible galaxies, even in principle, exceeds the total energy output of all the stars in our galaxy over billions of years. It is not merely impractical, it is physically impossible. But perhaps we are thinking about this problem in the wrong way. Perhaps there is some other approach, some technology that could circumvent these limitations. Science fiction often imagines warp drives, wormholes, hyperspace lanes, and other exotic mechanisms for traveling faster than light. Could any of these offer a way to the edge of the universe? Let us examine each possibility carefully, because they are fascinating ideas, and understanding why they do not solve our problem will deepen our understanding of the universe itself. Warp drives, as popularized by science fiction, imagine bending or warping space around a spacecraft so that it can effectively travel faster than light without actually moving through space faster than light. The space in front of the ship would contract, while the space behind it would expand, allowing the ship to surf along on a wave of distorted space-time. In 1994, physicist Miguel Alcubierre showed that such a configuration is theoretically consistent with general relativity. However, his calculations also showed that creating such a warp bubble would require enormous amounts of exotic matter with negative energy density, a type of matter that may not exist, and if it does exist, cannot be produced in the quantities required. The energy requirements are staggering. Various refinements of the idea have reduced, but not eliminated these requirements. Most physicists consider warp drives to be interesting thought experiments, but not realistic possibilities. Even if we could build a warp drive, it would not help us reach the edge of the universe. The reason is subtle, but important. A warp drive would let you arrive at a destination faster than light, traveling through normal space. But the edge of the observable universe is not a normal destination. It is defined by the expansion of space itself. A warp drive bends space, but it does not stop the overall expansion of the cosmos. The distant galaxies would still be receding, space would still be stretching, and the fundamental limit imposed by accelerating expansion would still apply. You might reach nearby galaxies faster, but the edge of the observable universe would still recede beyond your reach. What about wormholes? These are hypothetical tunnels through space-time that could connect distant points, allowing near instantaneous travel between them. Wormholes are solutions to Einstein's field equations, so they are mathematically possible within general relativity. However, all known wormhole solutions require exotic matter to keep them open and stable. Without this exotic matter, they would collapse instantly. And the amounts of exotic matter required are, again, beyond anything we could ever hope to produce. But let us imagine, for the sake of argument, that we could create and stabilize a wormhole. Could we use it to reach the edge of the universe? The answer is still no, because a wormhole would connect two specific points in space. You would need to know where the edge is and be able to place a wormhole endpoint there. But the edge of the observable universe is not a place. It is a horizon that shifts depending on where you are. A wormhole to one location would simply move your horizon, but not eliminate it. You would find yourself in a different place with a different observable universe, but there would still be regions beyond your reach. There is another fundamental problem with both warp drives and wormholes. They might allow for backward time travel, at least in certain configurations. Traveling faster than light, by any means, is equivalent to traveling backward in time in some reference frames. This creates paradoxes, like the famous grandfather paradox, where you could go back in time and prevent your own birth. Most physicists believe that the laws of physics must somehow prevent such paradoxes, perhaps by forbidding true faster-than-light travel entirely. This is known as the chronology protection conjecture, proposed by Stephen Hawking. If this conjecture is correct, then faster-than-light travel may be fundamentally impossible, not merely technologically difficult. So where does this leave us? We have established that the edge of the observable universe is not a fixed destination, but a receding horizon. We have established that the expansion of space is accelerating, causing this horizon to recede faster over time. We have established that the energy requirements for high-speed travel are prohibitive, and that even achieving speeds close to light would not allow us to reach most of the observable universe. And we have established that exotic technologies like warp drives and wormholes, even if they were possible, would not solve the fundamental problem. But we have not yet addressed the deepest version of the question. Is there an edge to the universe itself beyond the observable horizon? Is there a place where space ends, where the cosmos gives way to something else, where you could stand at the boundary and look outward into nothing? This is one of the most profound questions in cosmology, and the honest answer is that we do not know. We cannot observe beyond our cosmic horizon, so we cannot directly test what lies beyond. But we can reason about the possibilities based on the physics we do understand, and those possibilities are strange and wonderful. One possibility is that the universe is infinite. Not just very large, but truly infinite, extending forever in all directions. In an infinite universe, there is no edge. No matter how far you travel, there is always more space ahead. This is actually the simplest interpretation of our current cosmological models. The universe appears to be flat, meaning that its geometry is Euclidean at the largest scales. A flat universe can be finite only if it wraps around on itself in some exotic way, like the surface of a torus. But if it does not wrap around, it extends forever. An infinite universe is a humbling idea. It means that there are regions of space that have always been beyond our horizon and always will be. It means that the universe contains not just more galaxies than we can see, but infinitely more. It means that somewhere out there, unimaginably far away, there could be other planets, other civilizations, other beings looking up at their own night sky and asking the same questions we are asking, and we will never know they exist. Another possibility is that the universe is finite, but unbounded. This is the classic example of a surface with no edge, like the surface of a sphere. If you walk in a straight line on the surface of a sphere, you never reach an edge. You simply circumnavigate the sphere and return to where you started. The universe could be like this in 3 dimensions, though the geometry is harder to visualize. You could travel in a straight line forever without reaching an edge, but eventually, you might return to your starting point. This possibility is not currently favored by observations, which suggest the universe is flat rather than positively curved, but it cannot be definitively ruled out. A third possibility is that the universe is finite and has some kind of boundary, but this boundary is not a place in space. It could be a boundary in time. According to our best understanding, the universe had a beginning about 13.8 billion years ago. in an event we call the Big Bang. Before the Big Bang, there was no space and no time, at least not in any sense we can understand. The Big Bang was not an explosion in space, it was an explosion of space. If you tried to travel backward, in time far enough, you would not reach an edge of the universe. You would reach the beginning of the universe, the moment when time itself began. This is a kind of boundary, but it is not an edge you could visit in the normal sense. What about the future? If the universe is accelerating in its expansion, what is its ultimate fate? And does that fate involve any kind of edge? Current theories suggest that if dark energy continues to drive acceleration forever, the universe will expand without limit. Distant galaxies will recede beyond the horizon. Stars will burn out. Black holes will evaporate. The universe will approach a state of maximum entropy, a cold, dark emptiness stretching forever. This is sometimes called the heat death of the universe. In this scenario, there is still no edge in space, but there is an ending in a different sense, a gradual fading into stillness. There are more exotic possibilities. Some theories suggest that our universe is just one bubble in a vast multiverse, an infinite foam of universes with different properties. In this picture, the edge of our universe might be a boundary with another universe, though not one we could ever reach or detect. These ideas are speculative and untestable with current technology, but they hint at how strange the ultimate nature of reality might be. For now, let us return to the question we can address. Can humans ever travel to the edge of the observable universe, the cosmic horizon that marks the limit of what we can see? The answer is no. It is a gentle no, but it is a definitive no. The edge of the observable universe is not a destination we can reach. It is a horizon imposed by the structure of space-time itself, by the speed of light and the expansion of space. It recedes as we approach it, not because we are too slow, but because the universe is built this way. Even at the speed of light, we could not reach it. Even with technologies beyond our imagination, we could not reach it. It is not merely far away, it is unreachable in principle. But there is something important to understand here. This limitation is not a tragedy, it is not a prison. It is simply the nature of the cosmos, no more confining than the fact that we cannot see our own backs or travel to yesterday. The universe we can explore is still impossibly vast, containing billions of galaxies, each with billions of stars, each potentially harboring worlds we have never dreamed of. The limitation tells us something profound about the structure of reality, something worth knowing even if it means setting aside certain dreams. Let us now shift our perspective and think about what we can do rather than what we cannot. What would it mean to explore the accessible universe, the portion of the cosmos that is within our reach in principle? The accessible universe is still enormous. While we cannot reach galaxies that are receding faster than light, we can reach galaxies that are receding more slowly, provided we act soon enough. The local group of galaxies, including the Milky Way, Andromeda, and about 50 smaller galaxies, is gravitationally bound together. These galaxies will not be carried apart by the expansion of space. They will remain accessible, at least until some far distant future, when they merge into a single giant elliptical galaxy. Beyond the local group, Other galaxies in the Virgo supercluster and beyond may still be reachable, depending on how far they are and how the expansion continues. However, reaching even the nearest external galaxies is a challenge that dwarfs anything humanity has ever attempted. Andromeda is 2.5 million light-years away. At the speed of our fastest current spacecraft, about 17 kilometers per second, it would take over 40 billion years to get there, about 3 times the current age of the universe. This is clearly not practical, even at 1% of the speed of light, a speed that might be achievable with very advanced technology. The journey would take 250 million years. There are concepts for interstellar travel that could potentially achieve much higher speeds. Solar sails could be propelled by powerful lasers to a significant fraction of the speed of light. The Breakthrough Starshot initiative has proposed sending tiny probes to Proxima Centauri at about 20% of the speed of light, a journey that would take about 20 years. Larger ships carrying humans would face much greater challenges, including the need to accelerate and decelerate safely, protect passengers from radiation and micrometeorites, and sustain life for decades or centuries. These challenges are formidable, but perhaps not insurmountable over timescales of hundreds or thousands of years. If humanity survives and thrives, if we expand beyond Earth and establish ourselves on other worlds, if we develop technologies we can barely imagine today, then perhaps our distant descendants will spread across the galaxy. Perhaps they will send expeditions to Andromeda and other nearby galaxies. Journeys that take millions of years, but are undertaken anyway, because exploration is in our nature. Perhaps they will establish a civilization spanning millions of light years, connected not by instantaneous communication, which is impossible, but by something more like a cosmic network of isolated outposts, each developing its own culture over eons. But even in this most optimistic scenario, there will be limits. The accessible universe will slowly shrink as the expansion accelerates. Galaxies that were once reachable will cross beyond the horizon, one by one. The ultimate fate of any such civilization is isolation, not in any immediate or dramatic sense, but gradually, over billions of years, as the accessible cosmos contracts and the night sky empties. This is the deepest truth that emerges from our question. The universe is not designed for us. It does not conform to our desires or our intuitions. It operates according to its own laws, laws that we can discover and understand, but not change. The edge of the universe is not a wall we can climb or a shore we can reach. It is a consequence of the nature of space-time, a feature of reality that reveals the structure of existence itself. And yet, there is something beautiful in this. The limits of the cosmos are not arbitrary. They emerge from the same physics that gives rise to stars and galaxies, to planets and life, to consciousness and wonder. The speed of light is not just a barrier. It is also what makes causality possible, what allows events to have consequences, what permits the existence of meaningful sequence and story. The expansion of space is not just a receding horizon. It is also what gave the universe its structure, what allowed matter to cool and condense, what made galaxies and stars and planets, and eventually us. The limits and the possibilities are two sides of the same coin. When we ask whether we can travel to the edge of the universe, we are really asking about our place in the cosmos. We are asking whether we are confined or free. whether the universe is hospitable or hostile, whether our curiosity can ever be satisfied. And the answer is nuanced. We are confined in some ways and free in others. The universe is neither hospitable nor hostile. It is indifferent, following its laws without regard for our wishes. Our curiosity can never be fully satisfied because there will always be more to learn, more to discover, more to wonder about. This is not a limitation, but a gift, a universe we could fully explore and completely understand would be a much smaller thing in every sense that matters. Let us continue our journey by examining in more detail the relationship between distance and time in cosmology, because this is where some of our most stubborn intuitions begin to fail. In everyday life, distance and time are separate things. The distance from your home to your workplace is a certain number of kilometers, and the time it takes to get there depends on how fast you travel. You can measure distance in meters and time in seconds, and they seem like entirely different quantities. But in the realm of the very fast and the very far, distance and time become intertwined in ways that are difficult to grasp. Consider light, traveling at about 300,000 kilometers per second. This speed is so fast that light can circle the Earth more than 7 times in a single second. It is the fastest anything can travel through space. And because of this, the distance light travels in a given time becomes a natural measure of astronomical distances. A light year is the distance light travels in 1 year. A light second is the distance light travels in 1 second, about 300,000 kilometers. When you look at a star that is 100 light years away, you are seeing light that left that star 100 years ago. You are seeing the star as it was 100 years in the past. If that star exploded yesterday, you would not know about it for another 100 years when the light from the explosion finally reaches you. In a very real sense, looking out into space is the same as looking back in time. The further away something is, the further in the past you see it. This is why astronomers talk about the observable universe in terms of both distance and time. The cosmic microwave background radiation, the afterglow of the Big Bang, comes from a distance of about 46 billion light years, but it was emitted when the universe was only about 380,000 years old, roughly 13.8 billion years ago. When we observe this radiation, we are seeing the universe as it was in its infancy, even though the light has been traveling for almost the entire history of the cosmos. This intertwining of distance and time has profound implications for the concept of traveling to the edge. When we imagine traveling somewhere, we usually imagine arriving at a place that exists now. If I travel to Paris, I expect to arrive at the Paris that exists at the time of my arrival, not the Paris of a century ago. But when we talk about traveling to distant cosmic destinations, this expectation breaks down. The further away something is, the more outdated our information about it. By the time you could reach a galaxy 10 billion light years away, which you cannot, but suppose you could, the galaxy you observed before setting out would no longer exist in the same form. Stars would have died and been born. Civilizations might have risen and fallen. The galaxy itself might have merged with others. You would arrive not at the place you saw, but at whatever that place has become in the intervening eons. This is one reason why the concept of reaching the edge of the universe is so strange. The edge is not a place in the present. It is a view into the past. What we call the edge of the observable universe is the furthest point from which light has had time to reach us. But the light we receive from that edge shows us the universe as it was billions of years ago, very close to the Big Bang itself. If you could somehow travel to that location instantaneously, you would not find yourself at an edge. You would find yourself in a region of space much like our own, filled with galaxies that have evolved for billions of years. The edge would have moved, because the edge is defined by where light has not yet had time to reach, and that depends on where you are and when you are. Let us think about this more carefully with a thought experiment. Imagine that you have a magical ship that can teleport instantaneously to any location. You decide to teleport to the edge of the observable universe. Where do you end up? The answer depends on what you mean by the edge. If you teleport to the location where the light we currently see as the cosmic microwave background was emitted, you would find yourself in a region of space that looks essentially like our own. It would be full of galaxies and stars, none of which would be the original source of the cosmic microwave background, because those original sources have long since evolved into other things. You would have a new observable universe centered on your new location, extending in all directions, with its own cosmic microwave background coming from entirely different regions of space. The edge is not a thing or a place. It is a perspective. It is defined by the observer, not by any property of the universe at that location. This is a subtle but crucial point. There is no physical marker at the edge of the observable universe, no wall, no boundary, no sign saying you have reached the edge. There is just more universe, more space, more galaxies, receding into an endless extension that may continue forever. If you teleported to this new location and then looked back toward Earth, you would see our region of space as it was billions of years ago, long before the sun formed, long before the Earth existed. Earth would be beyond your new observable horizon. You could never receive any signal from Earth, never learn what happened there, never return. The teleportation, even if instantaneous, would be a one-way trip into isolation. This thought experiment reveals something important about the nature of travel in an expanding universe. Travel is not just about moving through space. It is about moving through a space that is itself changing, expanding, evolving. The destination you see is not the destination you would reach. The journey transforms the destination even as you travel toward it. This is perhaps the most disorienting aspect of cosmic travel. In everyday life, destinations are stable. The coffee shop you are walking toward does not drift away while you approach it. The airport does not recede as your taxi advances. But at cosmic scales, this stability vanishes. The expansion of space means that distant destinations are always changing their distance from you, even when neither you nor they are moving through space in the ordinary sense. And the farther away a destination is, the faster it recedes. This is not because distant galaxies are somehow fleeing faster. It is because the expansion of space is cumulative. Every megaparsec of space expands at the same rate. But if there are more megaparsecs between you and a destination, the total expansion is greater. Double the distance, double the recession. Triple the distance, triple the recession. At a certain distance, the recession exceeds the speed of light. This creates a fundamental limit that no technology can overcome. It is not a limit of engineering or energy. It is a limit of geometry, built into the structure of space-time itself. Let us now consider what this means for our understanding of the cosmos. We have developed, over the past few centuries, remarkable tools for exploring the universe. Telescopes that can see galaxies billions of light years away. Spacecraft that can travel to distant planets in our solar system. Probes that have left the heliosphere and entered interstellar space. Radio dishes that can detect faint whispers from the edge of the observable universe. These tools have expanded our knowledge enormously. We know more about the cosmos than any previous generation could have imagined. We have mapped the large-scale structure of the universe. We have measured the age of the cosmos to within a few tens of millions of years. We have detected gravitational waves from colliding black holes. We have photographed the shadow of a black hole at the center of a distant galaxy. All of this has been accomplished without ever traveling beyond our own planetary neighborhood. Our physical reach is still tiny, limited to the moon and a handful of robotic missions to other planets. But our cognitive reach extends across the observable universe. We can know things about objects we will never visit. We can understand processes we will never witness firsthand. We can map territories we will never walk. This is a different kind of exploration than the explorers of past centuries engaged in. When Columbus crossed the Atlantic, he brought back more than knowledge. He brought back physical contact, the beginning of a connection that would transform both the old world and the new. When astronauts walked on the moon, they did not just learn about lunar geology. They stood on another world, touched its rocks, left footprints that will last for millions of years. Cosmic exploration cannot offer this kind of physical contact, at least not for the vast majority of the cosmos. We will never stand on a planet in the Andromeda galaxy. We will never touch a rock from a star system a billion light years away. Our exploration of most of the universe will always be at a distance, mediated by light, limited to observation rather than participation. And yet, this kind of exploration is not lesser. It is different, certainly. It lacks the immediacy of physical presence. But it offers something that physical exploration cannot: scope. We can observe the entire observable universe from our vantage point on Earth. We can see further than we could ever travel. We can know more than we could ever visit. Consider what this means. A single astronomer, sitting at a computer terminal, can examine images of thousands of galaxies in an afternoon. They can measure the redshifts of these galaxies, determining how fast they are receding. They can estimate their distances, their masses, their ages. They can study their shapes and structures, identifying spiral arms and elliptical cores and irregular clumps. They can do all of this without ever leaving their chair, without traveling a single kilometer. This is exploration. It is real, meaningful, expanding our understanding of the cosmos. It does not require us to reach the destinations we study. It requires only that we receive the light they send us. And the cosmos sends us light generously. Every star shines in all directions, broadcasting its presence to any observer who happens to be in the path of its photons. Every galaxy is a beacon, visible across billions of light years to anyone with a telescope sensitive enough to catch its glow. The universe is not hiding from us. It is revealing itself, constantly, in the language of light. Our task is to learn that language, to build better telescopes, to develop more sensitive detectors, to create theories that explain what we see and predict what we will find. This is the exploration available to us, and it is vast, perhaps inexhaustible. The edge of the universe cannot be reached by travel, but it can be studied. It can be understood. It can be known in a deep and meaningful sense, even if it can never be visited. Let us think more deeply about what knowledge means in this context. When we say we know something about a distant galaxy, what do we mean? We mean that we have received information about it, encoded in the light that has traveled to us. We have analyzed this information, extracted patterns, drawn conclusions. We have built mental models that represent the galaxy, that predict its behavior, that connect it to other things we know. This knowledge is real. It is not merely belief or opinion. It is grounded in evidence, tested against observation, refined through the scientific process. When we say that a certain galaxy is 10 billion light years away and contains about 100 billion stars, we are stating facts, as firmly established as any fact about our immediate surroundings. But this knowledge has a peculiar character. It is knowledge about the past. The light from that galaxy left 10 billion years ago. The galaxy we see is the galaxy as it was then, not as it is now. We have no way to know what the galaxy looks like today. No way to receive information faster than light can carry it. In a sense, the observable universe is a vast archive of the past. Every direction we look back in time. The further we look, the further back we see. The cosmic microwave background, the most distant thing we can observe, shows us the universe as it was just 380,000 years after the Big Bang. We are seeing the infancy of the cosmos, preserved in light that has been traveling for almost 14 billion years. This is remarkable when you think about it. We have direct observational evidence of what the universe looked like shortly after its birth. We can study this evidence, analyze it, learn from it. We know more about the early universe than we know about many periods of Earth's own history, simply because the light has been preserved and delivered to us across the ages. The edge of the observable universe is, in this sense, a window into deep time. It shows us not the present state of the cosmos, but its ancient past. When we study the edge, we are studying origins. We are seeing how galaxies first formed, how structure emerged from the nearly uniform conditions of the early universe, how the cosmos evolved from simplicity to complexity. This is knowledge worth having. It tells us where we came from. In the most profound sense, it connects us to the history of the universe, shows us our place in the cosmic story. We are made of atoms that were forged in stars, and those stars formed from gas that coalesced out of the primordial plasma that we can still see in the cosmic microwave background. When we look at the edge of the observable universe, we are looking at our own origins, the conditions from which everything we know eventually emerged. And this knowledge does not require travel. It requires only attention, patience, and the right instruments. The universe is telling us its story. We just need to listen. Let us now consider the future, not of the universe, but of our understanding of it. We stand at a particular moment in the history of cosmic exploration. We have made enormous progress in the past century. We have gone from not knowing that other galaxies existed to mapping billions of them. We have gone from not knowing the age of the universe to measuring it with precision. We have gone from not knowing what powers the sun to understanding nuclear fusion in detail. What will the next century bring? The next millennium? The next million years? We cannot know for certain. The future of science is inherently unpredictable, but we can make some educated guesses. We will almost certainly build better telescopes. The James Webb Space Telescope, launched recently, is already revealing details about distant galaxies that were invisible to previous instruments. Future telescopes will see even further, with even greater clarity. We may eventually detect signs of the very first stars that formed after the Big Bang, or the earliest black holes, or other phenomena that are currently beyond our observational reach. We will likely develop new ways of observing the universe. Gravitational wave detectors have opened a new window on the cosmos, allowing us to sense events that produce no light, like the mergers of black holes. Future detectors may be far more sensitive, revealing gravitational waves from a wider range of sources. Neutrino observatories are another tool, detecting particles that pass through ordinary matter almost without interaction, carrying information from the cores of stars and supernovae. We may discover new physics. The current standard model of cosmology is remarkably successful, but it contains deep mysteries. Dark matter and dark energy together make up about 95% of the universe, but we do not know what they are. If we can solve these mysteries, our understanding of the cosmos will be transformed. New physics might reveal features of the universe that are currently invisible to us, or explain phenomena that are currently puzzling. We may develop new theoretical frameworks. General relativity and quantum mechanics are both spectacularly successful in their domains, but they are fundamentally incompatible. A theory of quantum gravity, which unifies these two frameworks, might give us new insights into the nature of space-time, the origin of the universe, and the ultimate fate of the cosmos. All of this will expand our knowledge of the universe, deepen our understanding, answer questions we are currently asking, and raise new questions we cannot yet imagine. The exploration of the cosmos has no obvious endpoint. There will always be more to learn, and this exploration does not require us to travel to the edge of the universe. It can proceed from our current vantage point, using the tools of observation and theory. The cosmos is large enough, complex enough, mysterious enough to occupy any civilization for any length of time. We will not run out of things to discover. This is the answer to the question we have been pursuing. Can we travel to the edge of the universe? No. But can we explore the universe? Yes. Can we understand it? Increasingly, yes. Can we find meaning in our relationship with the cosmos? Absolutely, yes. The edge is unreachable, but the exploration is not limited by that unreachability. The exploration continues, and it will continue as long as there are beings capable of wondering about the cosmos they find themselves within. Let us reflect now on the nature of limits. We have encountered many limits in our discussion. The speed of light is a limit. The expansion of space creates limits. The cosmic event horizon is a limit. The observable universe itself is a limit. Limits can feel like failures. They can feel like the universe saying no, like doors being closed, like possibilities being foreclosed. When we learn that we cannot travel to the edge of the universe, there is a sense of disappointment, a mourning for journeys that will never be taken. But limits also have a different character. They provide structure. They create definition. Without limits, there would be nothing to push against, nothing to work within, nothing to shape our efforts and give them meaning. Consider the limits that make music possible. A piano has only 88 keys. A guitar has only 6 strings. An octave has only 12 notes. These limits seem constraining, but they are also enabling. Within these constraints, infinite variety is possible. Every symphony, every sonata, every pop song exists within these limits. The limits do not impoverish music. They make it possible. The same could be said of the limits imposed by the cosmos. The speed of light seems like a barrier, but it also makes causality possible. It ensures that causes precede effects, that the universe has a coherent order. Without this limit, the universe might be a chaos of causal events, incomprehensible and unnavigable. The expansion of space seems like a loss, carrying galaxies beyond our reach. But it also gave the universe its structure. Without expansion, the cosmos would have collapsed back into the Big Bang, or would be a uniform soup of particles with no stars, no galaxies, no complexity. The expansion is why there is something rather than nothing, why there is structure rather than chaos. The observable universe seems like a prison, limiting what we can see and know, but it also provides a coherent view, a consistent story. Every observer sees a cosmos that is centered on themselves, with a horizon that defines what is accessible. This might seem egocentric, but it is also democratic. Every observer, everywhere in the universe, has the same relationship with the cosmos. No one is privileged. No one is deprived. The universe treats all observers equally. These limits are not arbitrary restrictions imposed from outside. They are the structure of reality. They emerge from the same physics that creates everything we see. They are woven into the fabric of the cosmos, not as flaws, but as features. Learning to accept limits is part of wisdom. A child might wish they could fly, or travel through time, or know everything at once. Growing up means accepting what is possible and working within it. This is not resignation. It is maturity. The same maturity is needed in our relationship with the cosmos. We cannot travel to the edge of the universe. Accepting this is not a defeat. It is an acknowledgement of reality, a recognition of structure, a foundation for meaningful exploration within the actual conditions of existence. And within those conditions, there is vastness beyond imagination. There are more stars in the observable universe than grains of sand on all the beaches of Earth. There are mysteries enough to occupy any civilization for any length of time. The limits do not make the cosmos small. They make it comprehensible, or at least approachable. A truly infinite cosmos, with no structure, no limits, no horizons would be overwhelming, perhaps even meaningless. The limits give us something to work with. The edge of the universe cannot be reached. But this is not the end of the story. It is just one chapter, one aspect of a larger truth. The story of our relationship with the cosmos is still being written, and it will be written by beings who accept the limits they cannot change while pushing the boundaries of what they can know. Let us consider now the emotional dimension of our question. There is something poignant about the unreachable edge. It speaks to a deep human longing, the desire to know what lies beyond, to see over the next horizon, to find out what is out there. This longing has driven exploration throughout human history. It took our ancestors out of Africa, across oceans to the moon. It is one of our most powerful motivations, and the cosmos seems to frustrate this longing. It offers horizons that can never be crossed, distances that can never be traveled, destinations that recede as we approach. The universe seems to be saying, you can look, but you cannot touch. You can see, but you cannot arrive. This can feel cruel. Why would the cosmos show us so much if we can never reach it? Why would it reveal billions of galaxies if we are trapped in our tiny corner? Why would it tease us with vastness if we are condemned to smallness? But perhaps this perspective misunderstands the situation. The universe did not reveal itself to us intentionally. It has no purposes, no intentions, no design. It simply is what it is, operating according to its own laws. The fact that we can see so much is a consequence of physics, not a cosmic gift or a cosmic taunt. Light travels, and we have eyes to receive it. That is all. And the longing we feel, the desire to reach the edge, is also not a cosmic truth. It is a human emotion, shaped by our evolutionary history, our particular kind of consciousness. Other beings, if they exist, might not share this longing. They might be perfectly content to observe without desiring to visit. They might find satisfaction in knowledge without needing contact. We can choose how to relate to our situation. We can mourn the unreachable edge, focus on what we cannot do, feel trapped and frustrated. Or we can appreciate the vastness we can see, focus on what we can know, feel wonder and gratitude. The cosmos does not dictate which response we choose. That is up to us. And there is much to appreciate. The fact that we exist at all is remarkable. The fact that the universe has produced beings capable of wondering about it is one of the most surprising features of existence. We are the cosmos becoming aware of itself. This is not a small thing. The edge is unreachable, but the wonder is right here. The appreciation is right here. The meaning we make is right here, in our response to what we know, in our relationship with the cosmos we find ourselves within. The universe is not withholding anything from us. It is revealing everything it can, given the laws of physics that govern it. The light reaches us. The information arrives. The knowledge is available. What we do with that knowledge, how we feel about it, what meaning we find in it, that is our contribution to the story. Let us think now about generations. Individual human lives are short by cosmic standards. A century, if we are fortunate. A tiny span of time, barely a heartbeat in the life of the universe. Within a single lifetime, we cannot travel to distant stars, let alone distant galaxies. The timescales of cosmic exploration exceed any individual, but humanity is not an individual. We are a species, a civilization, a continuing project that extends across generations. The knowledge gained by one generation is passed to the next. The questions asked by our ancestors become the answers known by our descendants. The exploration continues, even as individual explorers come and go. This changes the nature of our relationship with the cosmos. An individual might feel frustrated by the unreachable edge, but a civilization can take the long view. It can pursue projects that span centuries or millennia. It can accumulate knowledge incrementally, building understanding step by step, generation after generation. Consider what our ancestors, just a few centuries ago, knew about the cosmos. They knew the Earth was round, but they did not know its age. They knew the sun rose and set, but they did not know it was a star. They knew the stars were distant, but they had no idea how distant. They could not have imagined galaxies or the expansion of space or the cosmic microwave background. Their ignorance was vast, and yet they passed on what they knew. They built instruments and recorded observations. They asked questions and proposed theories. They laid foundations on which later generations could build. We are the heirs of this long process. We know vastly more than our ancestors did, not because we are smarter, but because we stand on their shoulders. We have the accumulated knowledge of centuries, refined and extended by each generation in turn, and our descendants will stand on our shoulders. They will know things we cannot imagine. They will have instruments we cannot conceive. They will ask questions we cannot formulate. The exploration will continue, and it will reach further than we can foresee. In this light, the unreachable edge is not so frustrating. It is a long-term project, a multi-generational endeavor. We will not reach it, but we will contribute to the understanding of it. Our descendants will not reach it either, but they will understand more than we do. The process continues indefinitely, always approaching, never arriving, but always progressing. This is a meaningful form of participation in the cosmos, not as travelers reaching a destination, but as contributors to an ongoing project. Not as individuals completing a journey, but as links in a chain of understanding that extends across generations. The edge of the universe cannot be reached by any generation, but the understanding of the cosmos can grow with each generation. And that growth is a form of exploration, a kind of progress, a meaningful relationship with the vast reality we find ourselves within. Let us now consider the question from the perspective of other possible observers. We have focused on human experience, human limitations, human aspirations. But the universe is not human. It does not revolve around us. If there are other intelligent beings in the cosmos, they face similar questions, similar limits, similar choices. Consider an observer in a galaxy far from our own, perhaps on the other side of the observable universe. What would they see when they look toward us? They would see what we see when we look toward them. Ancient light carrying information about the distant past. They would see our region of the universe as it was billions of years ago, long before the sun or earth existed. They would have no way to know that intelligent life has emerged here, because the light carrying that information has not had time to reach them. Their observable universe would be different from ours, centered on their location rather than ours. Some of the galaxies they can see, we cannot. Some of the galaxies we can see, they cannot. The edge of their observable universe would be in a different location than the edge of ours. But the structure would be the same. They would have a cosmic horizon. They would see galaxies receding. They would face the same limits we face. If they asked whether they could travel to their edge, the answer would be the same. No. This universality is significant. The limits we encounter are not peculiar to us. They are features of the cosmos itself, faced equally by all observers everywhere. We are not specially restricted. We are not uniquely imprisoned. The structure of space-time creates horizons for everyone. In a way, this is comforting. We are not alone in our limitations. Whatever beings exist in the cosmos, they share our situation. They look out at vastness they can see but cannot reach. They contemplate edges that recede beyond any journey. They face the same questions, and they discover the same answers. This shared condition is a kind of connection, not communication, which is impossible across such distances, but a structural kinship. We are all embedded in the same cosmos, subject to the same physics, bounded by the same horizons. We are fellow travelers, even if we can never meet. And if they are out there, they are engaged in their own exploration, building their own telescopes, developing their own theories, asking their own questions, contributing to their own understanding. The cosmic project of comprehension is not ours alone. It is distributed across the universe, wherever minds exist that are capable of wondering. This is a vast and beautiful idea, intelligence arising independently across the cosmos, each instance exploring its own corner of existence, each contributing to a kind of distributed understanding. We cannot know if this is true. We cannot confirm the existence of other intelligent life. But if it exists, it is likely engaged in the same project we are. The edge is unreachable for all. The exploration continues for all. Let us think now about the very long-term future. We have discussed the heat death of the universe, the ultimate fate towards which the cosmos appears to be heading. In this far future, stars will have burned out. Black holes will have evaporated. The universe will be a cold, dark expanse of particles approaching absolute zero. This future is unimaginably distant. The timescales involved are so large that they make the current age of the universe seem like the first instant. We are talking about times measured in numbers, with 100 digits or more. Timescales that dwarf any human conception of duration. And yet, from that far future, looking back, the current era would seem like a brief flash of brilliance. The era of stars, when matter could fuse and shine, would be a temporary phase in the history of the cosmos. The time when complexity was possible, when life could exist, when minds could wonder, would be a fleeting moment in the vast, mostly dark history of the universe. This is a melancholy thought, but there is another way to see it. We exist in this moment. We are part of this brief, brilliant era. We get to experience the universe when it is full of stars, when galaxies shine, when complexity flourishes. We are here now, in the cosmic morning, when everything is young and bright. The far future will come eventually, but it is not here yet. We have time, vast amounts of time by any human standard, billions of years before our sun exhausts its fuel, trillions of years before the last stars die. We are at the beginning, not the end, and during this time, exploration can continue, understanding can deepen, knowledge can grow. The cosmic project we are engaged in has room to expand, to develop, to mature. Whatever beings exist in the far future will inherit a cosmos that is darker, emptier, colder. But they will also inherit whatever understanding has been built up over the ages. They will know things we do not. They will have perspectives we cannot imagine. The edge of the universe is unreachable. But the time before the heat death is vast. And within that time, anything we can conceive of understanding might be understood. Let us now return, one final time, to the question we set out to answer. Can humans ever travel to the edge of the universe? We have explored this question from many angles. We have examined the scale of the cosmos, the expansion of space, the limits of travel, the nature of horizons. We have considered warp drives and wormholes, time dilation and energy requirements, the difference between observation and arrival. We have thought about what exploration means, what limits mean, what knowledge means, and we have arrived at an answer. The answer is no. We cannot travel to the edge of the universe. The edge is not a destination. It is a horizon, defined by the speed of light and the expansion of space. It recedes as we approach. It is unreachable in principle, not merely in practice. But this answer, though definitive, is not the end of the story. It is an opening to a deeper understanding. The universe is not a container with walls to be reached. It is a vast, dynamic, evolving reality of which we are a part. Our inability to reach its edge does not diminish us. It reveals the true nature of our situation. We are embedded in something immense, woven into a cosmic fabric that extends beyond any journey we could take. And this fabric is not inaccessible to us. We can know it. We can understand it. We can explore it through observation and theory, building pictures of the cosmos that are accurate, tested, reliable. We can participate in the cosmic story through understanding, even when we cannot participate through travel. This is meaningful. It is significant. It matters that beings exist who can grasp the structure of the cosmos, who can ask about edges and horizons, who can know that the universe had a beginning and will have an end. We are the universe contemplating itself. That is not nothing. That is something remarkable. The edge cannot be reached, but the wondering never ends. The exploration continues. The understanding deepens. And that, perhaps, is the true answer to our question. Not a yes or a no, but a transformation. The question itself changes as we pursue it. What began as an inquiry about travel becomes an inquiry about existence. What began as a desire to reach becomes a capacity to understand. We are part of the cosmos. The cosmos extends beyond any edge we could reach, but it does not extend beyond our ability to know it. In that sense, we are not limited. We are participants, observers, knowers. We are small, but we are not closed off. We are finite, but we are connected to infinity through understanding. The edge of the universe cannot be reached, but the universe can be known. And in knowing it, we find our place. The stars shine, the galaxies turn, space expands moment by moment, carrying everything outward. The cosmos unfolds according to its own laws, vast and indifferent and beautiful. And here we are, wondering about it all, asking questions, seeking answers, reaching toward understanding. This is the journey we are on, not a journey to the edge, which does not exist. A journey into knowledge, into wonder, into deeper and deeper appreciation of what is. The edge is unreachable. The journey is endless. The cosmos is home, and that is enough. More than enough. That is everything. Let us now venture further into the nature of cosmic distances, because there are aspects of this subject that reward deeper consideration. When we speak of distances in the universe, We use units that can seem abstract. Light years, parsecs, megaparsecs. These units are convenient for astronomers, but they can obscure the reality of what we are describing. Let us try to make these distances more vivid. A light year is the distance light travels in 1 year. Light moves at about 300,000 kilometers per second, which means in 1 year, it covers roughly 9.5 trillion kilometers. This is already a number that defeats ordinary intuition. 9.5 trillion kilometers. If you could drive a car at highway speed without stopping, it would take you about 100 million years to cover 1 light year. And the nearest star is 4.25 light years away. That means about 40 trillion kilometers. At highway speed, the journey would take over 400 million years. This is longer than complex life has existed on Earth. Longer than the dinosaurs lived. Longer than any span of time that has meaning in human experience. These are the distances to our nearest neighbors. The cosmic scale extends much, much further. The Milky Way galaxy, our home, is about 100,000 light years across. To cross it at the speed of light would take 100,000 years. At highway speed, the journey would take about 1 quadrillion years. That number has 15 digits. The current age of the universe, by comparison, has only 10 digits. And the Milky Way is just one galaxy among trillions. The observable universe extends about 46 billion light years in every direction. The total diameter is about 93 billion light years. These numbers are so large that they have essentially no meaning in human terms. They are not quantities we can feel or visualize. They are mathematical descriptions of a reality that exceeds any intuition. This is important to understand because it shapes how we should think about cosmic travel. The distances involved are not just large, they are incomprehensible. They are beyond any scale that evolution prepared our minds to handle. When we ask whether we can travel to the edge of the universe, we are asking about journeys that would take longer than the universe has existed, covering distances larger than any number we can really grasp. The answer is no, of course. But the depth of that no is worth appreciating. It is not a no that might someday become a yes with better technology. It is a no built into the structure of reality. The distances are simply too vast, and they are getting vaster by the moment as space expands. Let us consider this expansion more carefully. The expansion of space is happening everywhere, all the time. Right now, as you read this, the space between galaxies is growing. New distance is being created, not by objects moving through space, but by space itself stretching. On small scales, this expansion is negligible. The space between you and the nearest wall is technically expanding, but by an amount so small that it could never be measured. The space within our solar system is expanding, but the gravitational attraction of the sun holds everything together, overwhelming the expansion completely. Even within our galaxy, gravity dominates and the expansion has no noticeable effect. But on larger scales, where galaxies are separated by millions or billions of light years, expansion becomes the dominant factor. Galaxies that are not bound together by gravity are carried apart by the stretching of space. The further apart they are, the faster they recede from each other. This leads to a peculiar situation. A galaxy that is currently, say, 10 billion light years away from us is receding at a certain speed. A galaxy that is 20 billion light years away is receding at twice that speed. A galaxy that is 30 billion light years away is receding at 3 times that speed. The recession rate is proportional to the distance. At a certain distance, about 14 billion light years, the recession rate equals the speed of light. Beyond that distance, galaxies are receding faster than light. This sounds impossible. Nothing can travel faster than light. But the galaxies are not traveling through space faster than light. They are being carried by space. Space itself is expanding, and there is no limit to how fast it can expand. The galaxies are just going along for the ride. This means that most of the observable universe is already moving away from us faster than light. We can see these galaxies because the light we are receiving left them long ago, when they were closer and the recession was slower. But any new light they emit now will never reach us. The space between us is expanding too fast. This is a profound limitation. It means that we are not just unable to travel to these distant galaxies. We are unable to receive any new information from them. They are visible, but permanently out of contact. We are seeing their past, and we will never see their present or future. And the situation is getting worse. The expansion is accelerating. More and more galaxies are crossing beyond the point where their light can reach us. The portion of the universe we can observe and the portion we could theoretically reach is shrinking. This is the opposite of what we might hope. We might imagine that as time passes, we would see more of the universe, reach more of the cosmos. But the reverse is true. As time passes, we see less. The accessible universe is contracting. In the very far future, trillions of years from now, observers in our region of space will see almost nothing beyond their own merged galaxy. The cosmic microwave background will have redshifted to invisibility. All evidence of the Big Bang, of the expansion, of the trillions of other galaxies will be gone. Future astronomers will have no way to know what we know. The cosmos will have hidden itself. This is strange and somewhat melancholy, but it also underscores a point we have made before. We are fortunate to exist now. We live in an era when the universe still reveals its true nature. We can see the cosmic microwave background. We can observe distant galaxies. We can measure the expansion and understand the structure of the cosmos. This window will not last forever. We are in a privileged time, cosmically speaking. The knowledge we gather now is knowledge that may be impossible to gather in the far future. Let us think more about what it means to observe versus what it means to travel. Observation and travel are different modes of relating to the cosmos. They accomplish different things and are limited in different ways. When we observe, we receive information. Light brings us data about distant objects, their composition, their temperature, their motion, their age. This information travels at the speed of light, which is fast but not infinite. The information we receive is always about the past, never the present. The further away an object is, the older the information. When we travel, we change our location. We move from one place to another, bringing our physical presence to a new position in space. Travel is limited by the speed we can achieve, which is always less than the speed of light. For any destination, there is a minimum travel time, determined by the distance and the speed of light. These two activities have different horizons. The observational horizon is the edge of the observable universe, about 46 billion light-years away. This is the furthest distance from which we have ever received information. The travel horizon, the cosmic event horizon, is closer, about 16 billion light-years. This is the furthest distance we could ever reach, even with unlimited time and near light-speed travel. Everything we can travel to, we can also observe. But there is a vast region that we can observe but never travel to. The region between 16 and 46 billion light-years. This region contains trillions of galaxies, visible in our telescopes, permanently beyond our reach. This asymmetry is fundamental. Seeing further than you can reach is the normal condition in an expanding universe. The cosmos reveals itself to observation while withholding itself from contact. There is something poignant about this. We can see galaxies we will never touch. We can know about objects we will never visit. We can study in detail things that are forever beyond our grasp. But there is also something liberating. Our knowledge is not limited by our mobility. We can know far more than we can reach. The universe is accessible to understanding in ways it is not accessible to presence. This suggests a different relationship with the cosmos than the one we might initially imagine. We are not travelers exploring a territory. We are observers studying a vast display. The universe shows itself to us, and we attend to what it shows. This is a form of intimacy, even if it is not the form we might have expected. Let us now consider the concept of an edge from a different angle. We have said that the universe does not have an edge in the sense we intuitively imagine. There is no wall, no boundary, no place where the cosmos ends. But our intuition about edges is not entirely wrong. It is just misplaced. Edges are real. They exist everywhere in the universe. Every object has an edge, a boundary where it ends and something else begins. The Earth has an edge where rock meets atmosphere. The sun has an edge where the photosphere gives way to space. A galaxy has an edge where stars become sparse. These are local edges, boundaries within the universe. They are not edges of the universe, but they are real, and they are navigable. You can travel to the edge of the Earth, any point on its surface, and look outward. You can travel to the edge of the solar system and look outward. You can, in principle, travel to the edge of the galaxy and look outward. What you will see at each of these edges is more universe, more space, more objects. The edge of one thing is always the beginning of something else. There is no final edge, no ultimate boundary. This is what the cosmos is like. It is a nested structure of edges, each one leading to more space, more structure, more reality. You can travel from edge to edge, always finding more. But you never find an ultimate edge, a place where everything ends. This is counterintuitive, because our everyday experience involves ultimate edges all the time. The room you are in has walls. Beyond the walls is more room, but eventually, you reach the outer walls of the building, and beyond that is the outside. You can always find a frame, a container, a boundary that encloses whatever space you are in. The universe does not work this way. There is no frame, no container, no boundary. The cosmos is not embedded in anything larger. It is simply all there is, extending in all directions, perhaps infinitely. This is a difficult concept to accept. Our minds want frames. We want to know what something is inside of. But the universe is not inside of anything. It is the totality, the whole, the everything. Asking what is outside the universe is like asking what is north of the North Pole. The question assumes a framework that does not apply. Learning to think without frames is part of understanding cosmology. We have to let go of the assumption that everything is contained in something else. We have to accept that the cosmos is unbounded, even if it is finite. We have to embrace a structure that has no edges in the sense we are used to. This is challenging, but it is also profound. It reveals the true nature of existence, which is stranger and more wonderful than our everyday intuitions suggest. Let us now think about meaning. We have established that the edge of the universe cannot be reached. We have established that most of the cosmos is beyond our grasp. We have established that the accessible universe is shrinking as expansion accelerates. These are sobering truths. But do they diminish meaning? Do they make our existence less significant? Do they render our exploration pointless? The answer, I would suggest, is no. Meaning is not a function of size. A small thing can be profoundly meaningful. A large thing can be empty. The significance of our existence does not depend on how much of the cosmos we can reach. It depends on what we do with what we have. And what we have is remarkable. We have consciousness. We have the ability to wonder. We have the capacity to understand. We have the opportunity to explore, even if our exploration is limited to observation rather than travel. These are not small things. They are, arguably, the most significant things in the universe. Consciousness is rare, as far as we know. Intelligence is rare. The ability to comprehend the cosmos is exceedingly rare. We may be among the very few entities in existence that can ask the questions we are asking. This gives our existence a significance that has nothing to do with how far we can travel. We are significant because of what we are, not where we can go. We are significant because we are part of the universe that has become aware of itself. The edge is unreachable, but meaning is right here. It is found in the act of wondering, in the pursuit of knowledge, in the appreciation of what is. It is found in the relationships we have with each other and with the cosmos we inhabit. It is found in the stories we tell and the questions we ask. No journey to the edge of the universe could give us more meaning than we already have. The meaning we seek is not out there, waiting to be reached. It is here, waiting to be recognized. Let us consider the role of imagination in our relationship with the cosmos. We cannot travel to the edge of the universe, but we can imagine it. We can picture what it might be like to approach the cosmic horizon, to watch galaxies recede and redshift into invisibility, to feel the isolation of infinite distance. Imagination is a form of travel. It takes us places our bodies cannot go. It lets us experience, in some attenuated way, realities we will never directly encounter. When we imagine the edge of the universe, we are not engaging in idle fantasy. We are extending our understanding, exploring possibilities, contemplating structures. Imagination, guided by knowledge, is a tool of comprehension. Scientists use imagination constantly. They imagine what the universe looked like at the moment of the Big Bang. They imagine what it would be like to fall into a black hole. They imagine the far future, when stars have died and the cosmos is dark. These imaginative exercises are not separate from science. They are part of science, part of how we understand realities that are beyond direct experience. So when we ask about traveling to the edge of the universe, even knowing that such travel is impossible, we are engaging in a meaningful activity. We are using imagination to explore the structure of reality. We are pushing our understanding to its limits, testing our concepts against the actual nature of the cosmos. The answer is that we cannot travel to the edge. But the asking of the question, the imagining of the journey, the contemplation of what we would find, these are valuable activities. They expand our minds. They deepen our appreciation. They connect us to the vastness that surrounds us. Imagination is not a substitute for travel, but it is a form of exploration in its own right. And when physical travel is impossible, imagination becomes our primary mode of reaching beyond ourselves. Let us think now about the nature of knowledge. We have emphasized that understanding is a form of exploration, that knowing the cosmos is a way of relating to it, even when we cannot travel through it. But what is knowledge? What does it mean to know something about a distant galaxy, or about the structure of space-time, or about the expansion of the universe? Knowledge is not possession. When we know something about a distant star, we do not own the star. We do not have it in our grasp. We have a representation of it, a model, a description. Our knowledge is a structure in our minds that corresponds in some way to a structure in reality. This correspondence is not perfect. Our knowledge is always partial, always provisional, always subject to revision. We may think we know something, and later discover we were wrong. Our models of the cosmos are approximations, useful but incomplete. But this does not mean knowledge is illusory or worthless. Our models work. They make accurate predictions. They allow us to navigate reality, to anticipate events, to understand causes and effects. The correspondence between our knowledge and reality, though imperfect, is real and useful. When we know that the universe is expanding, we are not just making a noise with our mouths. We are describing something true, something verified by observation, something that structures how the cosmos actually behaves. This knowledge connects us to reality in a deep way, and this connection does not require travel. We can know about distant galaxies without visiting them. We can know about the Big Bang without having been there. We can know about the future of the universe without traveling forward in time. Knowledge transcends the limitations of physical presence. This is a remarkable feature of consciousness. We can know things that are far away, things that happened long ago, things that will happen in the future. Our minds can contain representations of realities we will never directly experience. This is a form of contact, even if it is not physical contact. When we know about the edge of the observable universe, we are, in a sense, there. Not physically, not in a way that would allow us to interact with it, but mentally. Our minds contain a representation of that distant place, a model that captures its essential features. This is not nothing. This is meaningful contact. The edge cannot be reached by our bodies, but it can be reached by our minds. And mental reach is a form of arrival. Let us now consider the question from the perspective of deep time. We have talked about the age of the universe, about 13.8 billion years. We have talked about the far future, trillions of years hence. Let us try to situate our current moment within this vast timeline. The universe began in an extremely hot, dense state about 13.8 billion years ago. For the first few 100 million years, there were no stars. The cosmos was a dark fog of hydrogen and helium, gradually cooling as space expanded. Then, about 200 million years after the Big Bang, the first stars ignited. These were massive, short-lived stars, burning through their fuel in a few million years, and then exploding, seeding the cosmos with heavier elements. Galaxies began to form about 500 million years after the Big Bang. Small clumps of stars merged into larger structures. Over billions of years, these structures evolved into the galaxies we see today. Spirals, ellipticals, irregulars, each containing billions or trillions of stars. Our own galaxy, the Milky Way, formed about 13 billion years ago, relatively early in cosmic history. Our Sun formed about 4.5 billion years ago, from a cloud of gas and dust that contained elements forged in earlier generations of stars. The Earth formed shortly after, from the debris left over from the Sun's formation. Life appeared on Earth about 4 billion years ago, shortly after the planet had cooled enough to be habitable. For most of Earth's history, life was microbial, single-celled organisms too small to see. Complex multicellular life appeared only about 600 million years ago. Dinosaurs dominated for about 165 million years. Humans, in their modern form, have existed for only about 300,000 years. Recorded history spans about 5,000 years. Modern science is only a few centuries old. We are newcomers. The universe was ancient before we existed. The cosmos had been expanding for billions of years before Earth formed. Stars had been burning and dying for generations before the sun ignited. We are latecomers to a story that began long before us, and the story will continue long after we are gone. The sun will burn for another 5 billion years. The Milky Way will endure for trillions of years. The last stars will burn out in about 100 trillion years. The cosmos will continue for timescales beyond comprehension. In this vast sweep of time, our existence is a brief moment, but it is our moment. We are here now in the cosmic morning, when the universe is young and bright and full of stars. We get to witness this era. We get to explore it, understand it, wonder at it. The edge of the universe is unreachable, but this moment is reachable. It is here, it is now, and it is extraordinary. Let us consider what it means to be part of the cosmos. We sometimes speak as if we are separate from the universe, looking at it from outside, but this is not accurate. We are not outside the universe. We are inside it, part of it, woven into its fabric. The atoms in your body were forged in the cores of stars that died before the sun was born. The oxygen you breathe, the carbon in your cells, the iron in your blood. These elements were created in nuclear furnaces billions of years ago and scattered through space by supernova explosions. You are, quite literally, made of star stuff. This connection is not metaphorical. It is physical. The matter that makes up your body has been part of the cosmos for billions of years. It has been in stars, in interstellar clouds, in the accretion disk that formed the sun. It will return to the cosmos when you die, becoming part of the earth, eventually being recycled into new structures, new forms, new beings. We are not visitors to the universe. We are expressions of it. We are patterns that the cosmos has formed, temporary arrangements of matter that have become aware of themselves. When we look at the stars, we are the universe looking at itself. This perspective changes how we might think about the unreachable edge. The edge is not something separate from us, something out there that we want to reach. The edge is part of the same cosmos we are part of. It is, in a sense, our own body at great distance. We cannot travel to the edge because we are already, in some sense, there. We are part of the structure that has an edge. We are embedded in the space-time that curves and expands. We are not outside looking in. We are inside, looking around. This does not make the edge reachable in a physical sense, but it changes the emotional register of the question. We are not prisoners trying to escape. We are participants in a vast structure, trying to understand our place within it. Let us now think about gratitude. It might seem strange to feel gratitude toward the cosmos. The universe is not a person. It has no intentions. It does not give gifts or receive thanks. And yet, there is something like gratitude that arises when we contemplate our situation. We exist. This is not necessary. There did not have to be a universe, or if there was a universe, it did not have to contain life, or if it contained life, that life did not have to be conscious. At every step, things could have been different, but they are as they are, and we are here. The cosmos has produced beings capable of appreciating it. This is remarkable. The universe could have been a vast, silent, unwitnessed expanse. Instead, it contains observers, minds that can grasp its structure and wonder at its beauty. Whether we call this gratitude or something else, there is a response that seems appropriate when we contemplate our existence. Not gratitude to anyone, since there is no one to thank, but gratitude as a mode of being, a way of receiving existence, an acknowledgement that what we have is remarkable and not to be taken for granted. The edge of the universe is unreachable, but existence itself is received. We are here. We can wonder. We can know. This is a gift, even if it is a gift from no one to no one. Let us consider the value of limits one more time. We have discussed limits as structure, as shape, as what makes meaningful exploration possible. But there is another aspect of limits worth considering. They teach humility. Humility is the recognition that we are not the center of existence, that the universe does not revolve around our desires, that reality has a structure independent of our wishes. The unreachable edge is a lesson in humility. It teaches us that some things are simply beyond us, not because we have failed, but because the cosmos is built that way. This is a valuable lesson. Without limits, we might imagine ourselves to be all-powerful, capable of anything, constrained by nothing. This would be a delusion, and delusions lead to poor decisions. Humility grounds us. It helps us see clearly. It allows us to work effectively within the actual conditions of existence. The edge is unreachable. Accepting this is an act of humility. And from this acceptance, clarity flows. We stop wasting effort on the impossible. We focus on the possible. We make progress where progress can be made. Humility is not weakness. It is wisdom. It is the recognition of reality as it is, rather than as we might wish it to be. The cosmos teaches humility to anyone who pays attention. The unreachable edge is one of its lessons. Let us now approach the end of our exploration. We have traveled far in thought, if not in space. We have considered the scale of the cosmos, the nature of expansion, the limits of travel, the meaning of edges. We have thought about observation and knowledge, imagination and humility, gratitude and meaning. And we have arrived at an answer to our question: can humans ever travel to the edge of the universe? No. The edge is not a destination. It is a horizon, a perspective, a feature of space-time that recedes as we approach. Travel to the edge is not merely difficult. It is impossible in principle. But this answer is not the end of our relationship with the cosmos. It is a beginning. It clears away a misconception and opens up a deeper understanding. We are not travelers seeking a destination. We are participants in a vast structure, observers of an immense reality, minds that have emerged from the cosmos and can know something about it. The edge is unreachable. The cosmos is knowable. These two truths sit together, not in contradiction, but in complement. They define our situation, our possibilities, our meaning. We are small. The universe is vast. We are brief. The cosmos is ancient. We cannot reach the edge. We can know that there is no edge to reach. And in this knowing, we find our place. Not at the center of the universe, which has no center. Not at the edge, which has no edge. But within the fabric, woven into the structure, part of the pattern that extends in all directions without limit. The stars continue to shine. The galaxies continue to turn. Space continues to expand. And here, on a small planet orbiting an ordinary star, beings made of atoms wonder about the cosmos that made them. This wondering is our gift and our task. It does not require travel. It does not require reaching edges. It requires only attention, curiosity, and the willingness to accept what is true. The edge of the universe cannot be reached, but the universe can be loved. And in loving it, in wondering at it, in trying to understand it, we fulfill the deepest purpose available to us. The exploration continues, not toward an edge, but into depth, not toward a boundary, but into understanding, not toward arrival, but into appreciation. The cosmos is vast. The edge is unreachable. And we are here, wondering, always wondering, forever wondering. This is enough. This is more than enough. This is everything. Let us carry forward one more consideration, one that touches on the nature of experience itself. When we ask whether we can travel to the edge of the universe, we are implicitly asking what it would be like to be there. We are imagining an experience, a perspective, a view. Travel, for humans, is always about experience. We go places to see things, to feel things, to have experiences we could not have at home. But the edge of the universe offers no special experience. If you could somehow arrive at the current location of the cosmic microwave background, you would find yourself in a region of space much like our own. There would be galaxies and stars and voids. There would be nothing marking this location as special. The edge would have moved, because the edge is defined by the observer, not by any property of the location itself. The experience at the edge would be disappointing, in a sense. There would be no wall to touch, no barrier to press against, no threshold to cross. Just more universe extending in all directions. The edge you traveled to would now be somewhere else. This tells us something important about what we are really seeking when we ask about the edge. We are not seeking a location. We are seeking an understanding. We want to know what the universe is, where it ends, how it is structured. These are questions about reality, not about experience. And these questions can be answered without travel. We can understand the structure of the universe from here. We can know that it has no edge, or that its edge is a horizon rather than a wall. We can grasp the geometry of space-time and the dynamics of expansion. We can achieve the understanding we seek without ever leaving our planet. The desire to travel to the edge is, at bottom, a desire to understand. And understanding does not require travel. It requires thought, observation, and the willingness to accept what we learn. This is liberating. We do not need to mourn the journeys we cannot take. The understanding we sought from those journeys is available to us here and now. The cosmos reveals its structure to observation. We can know what we wanted to know. The edge is unreachable, but the understanding we sought from reaching it is not. The understanding is here, available, accessible. We just need to attend to it. Let us consider finally the nature of the cosmos as a whole. The universe is everything that exists, at least everything in this existence. It includes all matter, all energy, all space, all time. It is the totality, the whole, the all. This totality is not a thing among other things. It is not an object in a larger space. It is the context within which all objects exist. Asking what is outside the universe is like asking what is outside of everything. The question assumes there is something else, but there is not. The universe is all there is. This means that the universe does not have an edge in the way that objects have edges. Objects have edges because they are surrounded by other things. The earth has an edge because it is surrounded by atmosphere and space. A rock has an edge because it is surrounded by air or water or vacuum. But the universe is not surrounded by anything. It is not inside anything. It is the totality, and totalities do not have outside edges. This is a difficult concept, and it is worth sitting with. We are used to things having insides and outsides. We are used to boundaries that separate one thing from another. But the universe is not one thing among others. It is the context for all things. It does not have an outside because there is nothing for it to be outside of. When we ask about the edge of the universe, we are applying a concept that does not apply. We are trying to treat the totality like an object when it is not an object. We are looking for a boundary that cannot exist because the universe has no exterior to be bounded from. Understanding this is one of the deepest insights we can gain from our question. The question dissolves when we understand what the universe actually is. We were asking about edges because we imagined the universe as a kind of large room. When we see that it is not a room, not a container, not an object, the question about edges loses its grip. The universe is not a place we are in. It is the totality of existence. We are part of it. The edge we imagined is a projection of our intuitions onto something that does not share them. And with this understanding, we can rest. Not because we have given up, but because we have arrived at clarity. The question has been answered, not with yes or no, but with a transformation of understanding. We see now what we could not see before. The edge was never there to be reached. The journey was never to a destination. The cosmos is not a room with walls. It is everything, unbounded, extending without limit. And we are within it, part of it, made of it, wondering about it. The stars shine on, the galaxies turn, space expands into more space. Light travels, carrying information across the void. Time passes, moment by moment, carrying the universe from past to future. And we are here, for this brief time, aware of all this, able to wonder, able to know, able to appreciate the vastness that surrounds us and the mystery that pervades us. The edge of the universe cannot be reached, but the universe can be experienced. This experience, this moment of awareness, this wondering, is our inheritance and our contribution. We add our wondering to the cosmos. We add our knowing to the totality. We are the universe becoming aware of itself. And in that awareness, something is completed that was not complete before. The edge is unreachable. The wondering is endless. The cosmos is home. And in this home, vast beyond measure, ancient beyond imagining, structured beyond our intuitions, we find our place. Not at the center, for there is no center. Not at the edge, for there is no edge. But here, in the midst of everything, surrounded by stars, embedded in time, alive with questions. The questions never end. The wondering never ends. The exploration never ends. And that is not a limitation. That is the gift. The edge of the universe cannot be reached, but the journey into understanding is infinite, and we are on that journey. Now, always, forever. The cosmos awaits our wondering. It has waited for billions of years. It will wait for billions more. And as long as beings exist who can wonder, the exploration continues. The edge recedes. The understanding grows. The mystery deepens. And we are here, part of it all, wondering our way through existence. This is enough. This is everything. This is home. Let us now explore further into the realms of space and time, continuing our contemplation of the cosmos and our place within it. There is something worth considering about the way light travels through the universe. Light does not simply traverse space like a car driving down a road. Light is a wave, a ripple in the electromagnetic field, propagating through the vacuum of space at a constant speed, regardless of the motion of its source or its observer. This constancy of light speed is one of the foundational discoveries of modern physics. It was this observation that led Einstein to develop special relativity, and from special relativity came our understanding of space-time as a unified structure rather than separate entities. When light travels across the cosmos, it carries with it a record of where it came from. The wavelength of light tells us about the temperature of the source. The spectrum tells us about the chemical composition. The redshift tells us how fast the source is moving away from us, and by extension, how far away it is. Every photon is a messenger. Every beam of light is a story. The universe is constantly broadcasting information about itself in every direction at the speed of light. We need only receive this information and learn to interpret it. This is what astronomers do. They collect photons, count them, measure their wavelengths, analyze their patterns. From these measurements, they reconstruct pictures of distant objects, determine their properties, trace their histories. It is a form of archaeology, but an archaeology of light rather than artifacts. Consider what it takes to observe a distant galaxy. The light from that galaxy left billions of years ago. It has been traveling through the universe ever since, crossing vast voids, passing by other galaxies, occasionally being bent by the gravity of massive objects. It arrives at Earth as a faint glow, barely distinguishable from the noise of the detector. But in that faint glow is encoded information about the galaxy. The shape of the spectrum tells us what elements are present. The brightness tells us how many stars the galaxy contains. The redshift tells us how fast it is receding. From these measurements, we can determine the galaxy's distance, its age, its mass, its history. This is remarkable when you think about it. We are reconstructing the properties of an object billions of light years away, using nothing but the photons that happen to reach us. We have no other access to that galaxy. We cannot send a probe to it, cannot visit it, cannot touch it. And yet we can know a great deal about it. This is the power of observation. It transcends the limitations of travel. It gives us access to realities that are physically beyond our reach. And the information we gather is not static. As we build better telescopes and develop more sensitive detectors, we see more. We see fainter objects, more distant objects, objects that were previously invisible. The observable universe is fixed in size, but our ability to observe within it continues to grow. The James Webb Space Telescope, which began operating recently, sees in infrared light, which allows it to observe objects that are invisible to optical telescopes. Many of the most distant galaxies emit most of their light in the infrared because the expansion of space has stretched their light to longer wavelengths. The Webb telescope can see these galaxies, revealing the universe as it was in its earliest eras. What we are learning is remarkable. We are seeing galaxies that formed just a few 100 million years after the Big Bang. We are watching the first stars ignite, the first structures emerge, the first steps in the cosmic dance that would eventually produce us. We are witnessing our own origins, preserved in light that has been traveling for almost the entire history of the universe. This is exploration in the deepest sense. Not the exploration of territories, but the exploration of time. We are traveling backward through cosmic history, seeing the past as it actually was, learning things that no one knew before. And this exploration requires no travel. It requires telescopes, detectors, computers, and the accumulated knowledge of generations of scientists. It requires patience, precision, and the willingness to follow the evidence wherever it leads. But it does not require us to leave our planet. The edge of the universe is unreachable, but the history of the universe is readable. And reading that history is one of the greatest adventures available to us. Let us think more about the cosmic microwave background, because it holds a special place in our understanding of the universe. The cosmic microwave background is the oldest light in the universe. It was emitted about 380,000 years after the Big Bang, when the universe had cooled enough for atoms to form. Before that moment, the universe was a hot plasma of free electrons and protons, opaque to light. Photons could not travel freely. They were constantly scattering off particles. But when atoms formed, the universe became transparent. Photons could suddenly travel unimpeded, streaming in every direction. The light from that moment has been traveling ever since, cooling and stretching as the universe expanded, until today it reaches us as microwaves with a temperature of about 2.7 degrees above absolute zero. This light surrounds us in every direction. It is everywhere. It is the most distant thing we can see, the furthest back in time we can observe with light. Beyond it, there is nothing to see, because the universe was opaque. The cosmic microwave background is extraordinarily uniform. It has the same temperature in every direction to within 1 part in 100,000. This tells us that the early universe was almost perfectly smooth, with only tiny variations in density that would eventually grow into galaxies and clusters. Those tiny variations are visible in the cosmic microwave background as faint patterns of slightly warmer and slightly cooler regions. These patterns have been measured with great precision by satellite missions, and they tell us a remarkable amount about the universe. From the patterns in the cosmic microwave background, we can determine the age of the universe, the geometry of space, the composition of matter and energy. We can test theories of the Big Bang and inflation. We can see the seeds of cosmic structure, the embryonic forms of the galaxies that would later fill the sky. This is all visible in light that has been traveling for almost 14 billion years. We are seeing the universe as a baby, just 380,000 years old. And from this view, we can reconstruct the entire history of the cosmos. The cosmic microwave background is the ultimate edge of the observable universe. We cannot see beyond it because there is nothing to see. But we can see it, and from what we see, we can learn an enormous amount. This is the power of observation. The edge of the observable universe is not a wall that blocks our view. It is a window into the deep past. And through that window, we can see farther back in time than any journey could take us. Let us now consider the concept of the multiverse, briefly and carefully. Some theories in physics suggest that our universe might not be the only one. There might be other universes, perhaps infinitely many, with different properties, different physical constants, different histories. This idea is called the multiverse. The multiverse is speculative. We have no direct evidence for it. We cannot observe other universes, and it is not clear that we ever could. The multiverse is an idea that emerges from certain theoretical frameworks, particularly from cosmological inflation and string theory, but it remains unconfirmed. If the multiverse exists, it would change the context of our question about the edge of the universe. Our universe would be one bubble among many, and the edge of our universe might be a boundary with another universe. But even in this scenario, we could not reach that edge. The multiverse, if it exists, is even more inaccessible than the distant reaches of our own cosmos. It is worth mentioning the multiverse because it reminds us of how much we do not know. Our understanding of the universe is remarkable, but it is also incomplete. There may be aspects of reality that are fundamentally beyond our ability to observe or test. The multiverse might be one such aspect. This uncertainty is not troubling. It is simply the condition of inquiry. We learn what we can learn, and we acknowledge what we cannot know. The universe may hold mysteries that will never be resolved. The multiverse may exist or may not. We do our best with the evidence we have. The edge of our observable universe is reachable by observation, if not by travel, but the edges of reality itself if there are such edges, may be forever beyond us. This is another limit, another boundary, another reminder of our place in the vastness of existence. Let us return now to the theme of time. Time in the universe is not like time in everyday experience. We are used to thinking of time as a uniform flow, the same everywhere, ticking away at a constant rate. But this is not how time actually works. According to general relativity, time is affected by gravity and by motion. Near a massive object, time passes more slowly than it does far from the object. For an object moving at high speed, time passes more slowly than for an object at rest. These effects are real and have been measured. Clocks on airplanes run slightly slower than clocks on the ground because of the combined effects of altitude and speed. The GPS satellites in orbit have to account for relativistic time dilation to maintain their accuracy. At cosmic scales, these effects become dramatic. Near the event horizon of a black hole, time slows to a crawl. For an object falling into a black hole, time inside the hole diverges infinitely from time outside. The singularity at the center of a black hole, if it exists, is not so much a place as an end of time, a boundary where time simply stops. The expansion of the universe also involves time. The universe has a finite age, about 13.8 billion years. Before the Big Bang, there was no time, at least not in any sense we understand. Time began with the universe. The beginning of the universe was also the beginning of time. This is hard to grasp. Our intuition tells us that time is a background, a stage on which events occur. But in physics, time is part of the structure of reality, inseparable from space, affected by matter and energy. Time is not absolute. It is relational. The edge of the universe in time is the Big Bang. We cannot travel to the Big Bang because travel requires time, and there was no time before the Big Bang. The temporal edge is not a destination. It is a boundary of existence itself. But we can observe the effects of the Big Bang. We can see the cosmic microwave background, the light from just after the beginning. We can detect the ratios of hydrogen and helium set in the first few minutes of cosmic history. We can measure the expansion rate, which traces back to the initial conditions. The beginning is accessible to observation, even if it is not accessible to travel. We can know a great deal about what happened at the start, even though we cannot go there. This is another example of how understanding transcends physical reach. The temporal edge of the universe is as unreachable as the spatial edge. But both are knowable, in the sense that we can learn about them through observation and theory. Let us think about the future in more detail. The universe is not static. It is evolving, changing, aging. The future will be different from the present, and the far future will be very different indeed. In about 5 billion years, the sun will exhaust the hydrogen fuel in its core. It will swell into a red giant, expanding to engulf the inner planets and scorching the Earth. Then it will shed its outer layers, leaving behind a white dwarf, a dense, slowly cooling remnant about the size of the Earth, but with the mass of the sun. The white dwarf will continue to cool for trillions of years, eventually becoming a black dwarf, a cold, dark object emitting no light at all. But this process is so slow that no black dwarfs yet exist in the universe. The cosmos is not old enough. Similar fates await most stars. The massive stars will die sooner, in supernova explosions, leaving behind neutron stars or black holes. The smaller stars will live longer, burning their fuel slowly, but eventually they too will exhaust their supply and fade away. In about 100 trillion years, the last stars will burn out. The era of stars, which began a few 100 million years after the Big Bang, will come to an end. The universe will be dark, lit only by the faint glow of cooling white dwarfs and the occasional flash of a stellar collision. The dark era will last far longer than the stellar era. For timescales that dwarf the current age of the universe, the cosmos will be a cold, dark expanse of stellar remnants, slowly cooling toward absolute zero. But even the remnants will not last forever. Over incredibly long timescales, protons may decay, matter may disintegrate, and the remnants of stars will evaporate. Black holes, which seem eternal, will slowly evaporate through Hawking radiation, emitting faint trickles of particles until nothing remains. The largest black holes, the supermassive black holes at the centers of galaxies, will be the last structures to disappear. They will evaporate on timescales of 10 to the power of 100 years, numbers so large that they have no meaning in human terms. After the black holes are gone, what remains? According to our current understanding, what remains is a thin soup of particles, mostly photons and electrons, spread across an ever-expanding space. The temperature will approach absolute zero. Nothing will happen. The universe will have reached maximum entropy, a state from which no further change is possible. This is the heat death, the final fate of the cosmos. It is not a dramatic ending. It is a quiet fading, a gradual winding down, an approach to eternal stillness. The heat death is unimaginably far in the future. We are living in the cosmic morning, when everything is young and bright. The long night lies ahead, but it is so far ahead that it has no bearing on our lives, or even on the lives of civilizations. And between now and then, there is time. Vast amounts of time. Time for exploration, for discovery, for understanding. Time for civilizations to rise and flourish. Time for intelligence to spread and deepen. The future is not just an ending. It is an immense expanse of possibility. Let us consider what it might be like to live in different eras of cosmic history. We live in the era of stars. Galaxies are bright. The cosmic microwave background is detectable. The expansion of the universe is measurable. We can see evidence of the Big Bang and make predictions about the far future. This is a rich era, full of information, full of structure, full of opportunity for understanding. Civilizations arising much later, after the accessible universe has contracted and the cosmic microwave background has faded, would live in a different cosmos. They would see fewer galaxies, perhaps only their own merged local group. They would have less evidence of the Big Bang, less ability to measure the expansion, less access to the history of the cosmos. Their observable universe would be smaller, their knowledge limited by the loss of information that comes with cosmic time. They might develop physics and astronomy, but they would have fewer clues to work with. The richness of evidence that we enjoy would be unavailable to them in an even more distant era. After the last stars have died, any intelligent life that somehow persisted would face a universe of almost unimaginable emptiness. No stars, no galaxies, no light except the faint glow of cooling remnants. The cosmic microwave background would be undetectable, redshifted to nothingness. the evidence of the Big Bang would be gone. Such beings, if they existed, would have no way to know the history of the universe. They could not discover the Big Bang because the evidence would have faded. They could not measure the expansion because there would be nothing left to measure. They would be cosmologically isolated, cut off from the past by the passage of time. This reminds us of our own good fortune. We exist in an era when the universe still reveals itself. The evidence is available. The history is accessible. We can learn things that future civilizations may never be able to discover. This is another reason to appreciate our cosmic moment. Not just because the universe is beautiful, but because it is still readable. The story is still visible. The past is still accessible. The edge of the universe is unreachable. But the story of the universe is readable, at least for now. And reading that story is a privilege that may not last forever. Let us think about consciousness and its role in the cosmos. Consciousness is the most intimate thing we know. It is our experience of being, our awareness of ourselves in the world. Everything we know about the universe, we know through consciousness. All our observations, all our theories, all our understanding, these exist within conscious minds. And yet consciousness is also deeply mysterious. We do not understand how it arises from physical processes. We do not know why there is something it is like to be a conscious being, rather than just unconscious processing of information. The hard problem of consciousness, as philosophers call it, remains unsolved. What we do know is that consciousness exists, at least in us and probably in other creatures. We know that it is connected to the brain, that damage to the brain affects consciousness, that the complexity of the brain seems related to the richness of experience. We also know that consciousness is rare in the universe, as far as we can tell. Most of the cosmos is dead matter, lifeless rocks and gas and radiation. Only on certain planets, where conditions are right, does life arise. And only in certain forms of life does consciousness appear. We might be among the few conscious beings in the cosmos, or there might be many others. We do not know. The search for extraterrestrial intelligence has not yet succeeded, and we have no evidence of consciousness anywhere except on Earth. If consciousness is rare, then it is precious. It represents something remarkable in the universe, the emergence of awareness, the cosmos becoming conscious of itself. We are the universe looking at itself, wondering about itself, trying to understand itself. This gives our existence a significance that does not depend on our ability to travel. We matter not because of where we can go, but because of what we are. We are conscious beings, capable of wonder, capable of knowledge, capable of appreciating the vastness that surrounds us. The edge of the universe is unreachable, but the experience of being, the awareness of existing in this vast cosmos, this is available to us right now. This is the deepest kind of exploration, the exploration of consciousness itself. Let us consider the vastness of space one more time. Space is not just big, it is empty. The average density of matter in the universe is about 1 atom per cubic meter. That is a level of emptiness that is hard to imagine. The best vacuums we can create in laboratories are millions of times denser than the average density of space. Even within galaxies, where matter is concentrated, The distances between stars are immense. If the sun were a grain of sand in Los Angeles, the nearest star would be another grain of sand in San Francisco. The space between them would be essentially empty. This emptiness is part of why the universe feels so vast. It is not just that distances are large, it is that there is so little to fill those distances. Matter is scattered thinly across an enormous expanse, like a few drops of water spread across an ocean. The emptiness of space is also why the night sky is dark. If the universe were infinite in extent and eternal in age, and filled uniformly with stars, then every line of sight would eventually end at a star, and the night sky would be as bright as the surface of the sun. This is called Olbers's paradox. The resolution of Olbers's paradox involves both the finite age of the universe and the expansion of space. The universe is not eternal. It had a beginning, and light from very distant stars has not had time to reach us. And the expansion of space redshifts the light from distant galaxies, shifting it to lower energies and making it fainter. The darkness of the night sky is evidence of the nature of the cosmos. It tells us about the age and expansion of the universe. Even something as simple as looking up and seeing darkness is a window into cosmology. The edge of the universe is unreachable, but the nature of the universe is revealed in every observation, even in the darkness between the stars. Let us think about the relationship between science and wonder. Some people worry that scientific understanding diminishes wonder. They fear that explaining things, reducing them to physical processes and mathematical laws, somehow makes them less marvelous. They prefer mystery to knowledge. This is a misunderstanding. Scientific understanding does not diminish wonder. It deepens it. The more we learn about the universe, the more remarkable it becomes. The more we understand, the more we appreciate. Consider the stars. To ancient peoples, the stars were mysterious lights in the sky, their nature unknown. To us, the stars are nuclear furnaces, converting hydrogen into helium through fusion, releasing energy that lights the cosmos. We know how they are born, from clouds of gas, how they burn through their fuel over billions of years, how they die in explosions that scatter their elements across space. This knowledge does not make the stars less wondrous. It makes them more wondrous. We see not just points of light, but engines of creation, the forges where the elements of life are made. Our understanding enriches our appreciation. The same is true for the universe as a whole. The more we learn about its structure, its history, its fate, the more remarkable it seems. The Big Bang, the expansion of space, the formation of galaxies, the emergence of life, the evolution of consciousness. These are stories of cosmic grandeur, made richer by our understanding of them. The edge of the universe is unreachable, but in learning this, we have not lost something. We have gained something. We have gained a clearer picture of reality, a deeper appreciation of our situation, a more profound sense of wonder. Science and wonder are not opposed. They are allies. Science provides the raw material for wonder, the facts and stories and insights that fuel our appreciation of existence. Wonder provides the motivation for science, the curiosity and awe that drive us to understand. The cosmos is a source of endless wonder. The more we learn, the more wonderful it becomes. There is no danger of running out of wonder. The universe is inexhaustible. Let us now approach the conclusion of our exploration. We have ranged widely in this contemplation. We have considered the scale of the cosmos, the nature of expansion, the limits of travel, the power of observation. We have thought about time and consciousness, science and wonder, limits and meaning, and we have arrived at a place of understanding. The edge of the universe cannot be reached. But this is not a failure, it is a revelation. It reveals the true nature of the cosmos, which is vaster and stranger than our intuitions suggest. The universe is not a room with walls. It is not a container with boundaries. It is the totality of existence, extending in all directions, evolving through time, structured by laws we can discover and understand. We are part of this structure. We are woven into this fabric. We are made of the same matter that fills the cosmos, governed by the same laws that shape the galaxies. We are not separate from the universe. We are expressions of it. And as expressions of the universe, we can know it. We can observe it, study it, understand it. We can grasp its structure and appreciate its beauty. We can wonder at its vastness and find meaning in our place within it. The edge is unreachable, but the universe is knowable. And in knowing it, we participate in something larger than ourselves. We become part of the cosmic story of understanding. This is enough. This is more than enough. This is the gift of existence. The stars shine on. The galaxies turn. Space expands, moment by moment, carrying everything outward. The cosmic microwave background whispers of the beginning. The distant galaxies recede toward invisibility, and here, on a small planet, in a quiet corner of an ordinary galaxy, beings made of atoms contemplate the cosmos that made them. This is who we are. This is where we are. This is what we can know. The edge of the universe cannot be reached, but the wonder is right here, and it always will be. The exploration continues, the understanding deepens, the appreciation grows, and we are part of it, now and always. The cosmos is vast beyond measure. The edge is beyond reach, but the wonder is immediate, available, present, in every glance at the night sky, in every thought about the distant galaxies, in every moment of appreciation for the vastness that surrounds us. The universe has given us the gift of awareness. We can see it, know it, wonder at it. This is not a small thing. This is remarkable. The edge of the universe cannot be reached, but the universe can be loved. And in loving it, we find our home. Forever reaching, forever wondering, forever home. Let us continue our journey through the cosmos a while longer, exploring further depths and dimensions of this vast reality we find ourselves within. There is something worth considering about the nature of scientific discovery and how it shapes our understanding of the universe. Throughout history, our picture of the cosmos has changed dramatically. Each era has had its own cosmology, its own understanding of how the universe is structured and what lies beyond the familiar. For thousands of years, humans believed the Earth was the center of the cosmos. The sun, moon, planets, and stars all revolved around us. The universe was relatively small, bounded by a sphere of fixed stars not too far beyond the orbit of Saturn. This geocentric model made intuitive sense and matched casual observation. Then came Copernicus, and later Kepler and Galileo, and the picture changed. The Earth was not the center. The Sun was. The Earth was just one planet, among several, orbiting a central fire. The universe expanded in human imagination to encompass the distances between planets. Later still, we learned that the Sun was not the center either. Our Sun was one star, among billions in a vast galaxy. The Milky Way stretched across 100,000 light-years, far larger than anything previously imagined. The universe expanded again, in our understanding, to galactic scales. And then came the discovery that the Milky Way was not alone. What astronomers had called nebulae were actually other galaxies, island universes, each containing billions of stars. The universe expanded once more to encompass not just one galaxy, but billions of them, scattered across a cosmos of unimaginable immensity. Each of these expansions challenged human assumptions. Each displaced us further from any central position. Each revealed a universe larger and stranger than the one before, and at no point did we reach an edge. This history suggests something important. Our intuitions about edges and boundaries, about centers and limits, have consistently been wrong. The universe has always turned out to be larger than we imagined, less centered on us, less conforming to our expectations. The current understanding that the universe has no edge in the sense we intuitively imagine is a continuation of this pattern. We have moved from a small, bounded cosmos centered on Earth to a vast, possibly infinite cosmos with no center and no edge. Each step has required us to surrender comfortable assumptions and embrace a stranger truth. And each step has been worth taking. The universe revealed by science is more remarkable than the universe imagined by our ancestors. The vastness is not diminishing. It is awe-inspiring. The lack of edges is not disappointing. It is profound. The history of cosmology is a history of expanding horizons. Not physical horizons, which we have barely pushed beyond our own planet, but conceptual horizons. Our understanding has grown enormously, even as our physical reach remains limited. This is the kind of exploration that is available to us. Not the exploration of territories, but the exploration of ideas. Not the discovery of new lands, but the discovery of new truths. This exploration has no obvious end. There is always more to learn, always deeper questions to ask, always further horizons to pursue. Let us think more about the relationship between the observer and the universe. In classical physics, the observer was thought to be separate from the observed. The scientists looked at the universe from the outside, recording data, forming theories, but not affecting what was studied. The universe was like a machine that could be examined without being disturbed. Quantum mechanics changed this picture. In quantum theory, the act of observation affects the system being observed. Particles do not have definite properties until they are measured. The observer is entangled with the observed, part of the same quantum system. This has led some physicists and philosophers to wonder about the role of consciousness in the universe. If observation affects reality, and if observation requires consciousness, then what is the relationship between consciousness and the cosmos? We do not have clear answers to these questions. Quantum mechanics is well established experimentally, but its interpretation remains controversial. Some physicists believe that consciousness plays a special role. Others believe that the observer can be any physical system, not necessarily a conscious one. What we can say is that the universe has produced beings capable of observing it. We are not outside the cosmos, looking in. We are inside, looking around. Our observations are part of the cosmic process, not separate from it. This gives our observation a certain dignity. We are not irrelevant to the universe. We are, in some sense, its eyes. Through us, the cosmos sees itself. Through our telescopes and theories, the universe comes to know itself. The edge of the universe is unreachable, but the observation of the universe is happening right now, through us. We are participants, not just spectators. Our wondering is a cosmic event. Let us consider the role of mathematics in our understanding of the cosmos. Mathematics is the language of physics. The laws of nature are expressed in mathematical form. The expansion of the universe is described by equations. The behavior of light is captured in mathematical models. The structure of space-time is a geometric structure, describable by the mathematics of curved surfaces. This is remarkable when you think about it. Why should the universe be mathematical? Why should abstract structures, developed by human minds, turn out to describe the physical world so accurately? This is sometimes called the unreasonable effectiveness of mathematics. We do not have a definitive answer to this question. Perhaps the universe is inherently mathematical, built on a foundation of mathematical structures. Perhaps mathematics is simply the best tool we have developed for describing patterns, and the universe is full of patterns. Perhaps there is something about the nature of mind and reality that makes this correspondence possible. Whatever the explanation, the fact remains that mathematics works. We can use equations to predict the behavior of distant galaxies, the expansion of space, the radiation of black holes. Our mathematical models match observation with astonishing precision. This gives us confidence that our understanding is on the right track. The universe is not random or chaotic. It follows laws that we can discover and describe. The edge of the universe may be unreachable, but the laws that govern the universe are accessible to mathematical investigation. And through mathematics, we can explore realms that are physically inaccessible. We can calculate what happens at the center of a black hole, even though we cannot go there. We can model the conditions at the Big Bang, even though we cannot observe them directly. We can predict the far future, even though we will not be there to see it. Mathematics extends our reach beyond our physical limitations. It is another form of exploration, another way of engaging with the cosmos. Let us think about the relationship between knowledge and mystery. Some people assume that knowledge and mystery are opposed. The more we know, the less mystery there is. Science, on this view, is a process of demystification, reducing the unknown to the known, eliminating the mysterious. But this is not how science actually works. In practice, every answer generates new questions. Every discovery reveals new mysteries. The more we learn, the more we realize we do not know. Consider dark matter. A century ago, we did not know dark matter existed. We thought the universe was made of ordinary matter, the atoms we are familiar with. Then observations of galaxies revealed that something was wrong. Galaxies were rotating too fast. They should have flown apart. Something invisible was holding them together. We now know that this invisible something, dark matter, makes up about 27% of the universe. but we do not know what it is. Despite decades of searching, we have not directly detected a dark matter particle. The nature of dark matter remains one of the great mysteries of cosmology. This is a new mystery created by knowledge. Before we knew about dark matter, we did not know there was a mystery to solve. Our knowledge of galactic dynamics revealed a gap in our understanding. The more we learned, the more mysterious the universe became. The same is true for dark energy, the mysterious force driving the accelerating expansion of the universe. Before 1998, we did not know the expansion was accelerating. The discovery revealed a new mystery, one that we still do not understand. The universe is full of mysteries, and our exploration generates more of them. This is not a failure of science. It is the nature of inquiry. We are finite beings trying to understand an infinite cosmos. There will always be more to learn, more to wonder about, more mysteries to explore. The edge of the universe is unreachable, but the mysteries of the universe are inexhaustible. There is no danger of running out of questions. The cosmos will always be more than we can fully comprehend. Let us return to the theme of human nature and our place in the cosmos. We are a curious species. We ask questions. We seek answers. We explore, whether the territory is physical, intellectual, or spiritual. This curiosity is one of our defining characteristics, and the cosmos is a vast territory for curiosity. It offers more questions than we could ever answer, more wonders than we could ever exhaust. The universe is, in a sense, a perfect companion for a curious species. It will never bore us. It will never run out of surprises. The edge of the universe cannot be reached, but the exploration of the universe can continue indefinitely. As long as there are beings who wonder, there will be wondering to do. As long as there are questions, there will be questions to pursue. This is reassuring in a way. We do not need to worry about reaching the end of knowledge, about exhausting the mysteries, about finding ourselves with nothing left to learn. The cosmos guarantees that there will always be more. The vastness ensures that wonder is inexhaustible. Let us think about what we might call cosmic humility. Cosmic humility is the recognition of our smallness in the face of the universe's vastness. It is the awareness that we are not the center of existence, that the cosmos does not revolve around us, that our concerns and desires are not the concerns and desires of the universe. This might sound like a recipe for despair. If we are so small, so insignificant, so marginal, what is the point of our existence? But cosmic humility is not despair. It is a kind of liberation. It frees us from the burden of cosmic importance. We do not need to be the center of the universe. We do not need to matter on a cosmic scale. We can simply be what we are, small beings on a small planet, wondering about the vastness around us. And in that wondering, we find meaning. Not meaning imposed from outside, but meaning created from within. The meaning of our existence is not given by the universe. It is something we make through our choices, our relationships, our efforts to understand and appreciate. The cosmos is indifferent to our meaning-making. It does not care whether we find meaning or not. But this indifference is not hostility. It is simply neutrality. The universe provides the stage on which we act. What we do on that stage is up to us. Cosmic humility also has practical benefits. It helps us see ourselves in perspective. Our conflicts, our anxieties, our ambitions are real and important to us, but they are not cosmically significant. This perspective can be calming. It can help us let go of petty concerns and focus on what truly matters. The edge of the universe is unreachable, but cosmic humility is achievable. And from that humility, a kind of peace can flow. Let us consider the far future of intelligence in the universe. We have discussed the far future of the cosmos, the heat death that awaits in the unimaginably distant future. But what about the future of intelligence? What might happen to conscious beings over cosmic timescales? This is speculative, of course. We do not know what forms intelligence might take, what technologies might be developed, what civilizations might arise. But we can imagine possibilities. One possibility is that intelligence spreads across the accessible universe. Civilizations arise, develop technology, and expand into space. Over millions or billions of years, intelligent life fills the galaxy, then spreads to other galaxies within the local group. A cosmic civilization emerges, spanning millions of light years. Such a civilization would face the limits we have discussed. It could not reach the edge of the observable universe. It could not communicate faster than light. It would be bounded by the cosmic event horizon, confined to the accessible portion of the cosmos. But within those limits, it could achieve remarkable things. It could harvest the energy of stars, manipulate matter on vast scales, accumulate knowledge over billions of years. The intelligence of such a civilization might be as far beyond us as we are beyond bacteria. Another possibility is that intelligence transcends biology. Biological beings like us are fragile, short-lived, limited in many ways. But intelligence might not be inherently biological. It might be possible to create artificial minds, to upload consciousness into non-biological substrates, to build forms of intelligence that are not subject to biological constraints. Such post-biological intelligence might survive long after biological life has become impossible. It might persist into the dark era, after the stars have burned out, finding ways to exist and think in a cosmos of cold and darkness. Or perhaps not. Perhaps there are limits to what intelligence can achieve, limits we cannot foresee. Perhaps the universe is ultimately inhospitable to mind, and all intelligence will eventually cease. We do not know. The far future is deeply uncertain, but the possibilities are fascinating to contemplate. The edge of the universe is unreachable by any intelligence, no matter how advanced. This is a limit that cannot be overcome by technology or time. But within that limit, the possibilities for intelligence may be vast. Let us think one more time about the question we have been exploring. Can humans ever travel to the edge of the universe? We have answered this question thoroughly. The answer is no. The edge is not a destination. It is a horizon, a perspective, a feature of space-time. It cannot be reached because it is not a place to be reached. But the question itself is valuable. It led us to think deeply about the nature of the cosmos, the limits of travel, the power of observation. It led us to consider space and time, knowledge and mystery, meaning and wonder. The question is better than any simple answer. It opens doors that remain open. It starts explorations that never end. It is the kind of question that changes how we see everything, and this is perhaps the deepest truth of all. The value of a question is not always in its answer. Sometimes the value is in the asking, in the exploration the question provokes, in the understanding that emerges from thinking deeply about something we cannot resolve. The edge of the universe cannot be reached, but the question of whether we can reach it has taken us far. It has taken us across the cosmos, through space and time, into the depths of physics and the heights of philosophy. It has shown us what we are and where we stand. This is the gift of a great question. It is not the answer that matters. It is the journey. And our journey, though it leads to an unreachable destination, has brought us somewhere worthwhile. It has brought us to a deeper understanding of existence, a greater appreciation of our situation, a more profound sense of wonder. The cosmos is vast. The edge is unreachable. But we are here, wondering. And that wondering is itself a form of arrival. We have arrived at understanding. We have arrived at appreciation. We have arrived at wonder. And these are destinations worth reaching. Let us carry these thoughts with us as we conclude our exploration. The universe we have contemplated is the same universe that surrounds you now. The same stars that burn in distant galaxies are the stars whose light reaches your eyes when you look up at night. The same expansion that carries distant galaxies beyond our reach is happening right now, this very moment, in the space around you. These are not abstract facts. They are the reality of your existence. You are embedded in this cosmos. You are part of this structure. The atoms in your body, the thoughts in your mind, the wonder you feel, all of these are expressions of the same universe we have been discussing. When you look at the night sky, you are not looking at something separate from yourself. You are part of the system you are observing. The boundary between observer and observed is not as sharp as it might seem. You are the cosmos looking at itself. This perspective can change how you experience the world. Every moment becomes an opportunity for appreciation. Every glance at the stars becomes a meditation on your place in the vastness. Every thought about the universe becomes a thought about yourself, about your origins, about your connection to everything that exists. The edge of the universe is unreachable, but the universe itself is right here. It is in the air you breathe, the ground you stand on, the light that enters your eyes. It is in the atoms of your body, forged in stars that died before the sun was born. It is in the thoughts of your mind, the product of billions of years of cosmic evolution. You are the universe, wondering about itself. This is not a metaphor. It is the literal truth of your existence. And in that truth, there is a kind of belonging that transcends any journey. You do not need to travel to the edge of the universe to be part of it. You already are part of it. You have always been. You always will be, in one form or another. The matter that makes you will continue long after you are gone. It will become part of the earth, then perhaps part of other living things, then eventually part of whatever the earth becomes as the sun ages and dies. In the very long term, your atoms might be scattered across space, might become part of new stars and new planets, might participate in cosmic events we cannot imagine. You are not just here for a moment. You are here as part of an ongoing process, a cosmic story that began long before you and will continue long after. Your existence is a chapter in a book that has no final page. The edge of the universe is unreachable, but you are already part of the universe, and that belonging is deeper than any journey could provide. The stars shine on, the galaxies turn, space expands, moment by moment, carrying everything outward. And we are here, part of it all, thinking about it all, loving it all. The edge of the universe cannot be reached, but we have reached something else, something better, something that will stay with us as long as we continue to wonder. The cosmos is home, and home is where we are, now and always, forever wondering, forever reaching, forever home.